measurement? I don't know. So Anthony did that. I was part of it. Now, like I said, it shocked me. So Anthony, having discussed problems with the raw surface data, we've got he's going to discuss that first panel. We've got two speakers that come after him. They are Willie Soon, who I'm honored to have worked with for more than a decade now. He is one of the foremost experts on the influence of the sun or solar cycles on moderating or enhancing global temperatures over various lengths of time. And that's what he's going to discuss today. Imagine that the sun might have an impact on the temperature of the Earth. You wouldn't know that from climate models, by the way. Wrapping up our panel is Joe Bastardi, who after working for 32 years as a meteorologist at AccuWeather, he became the chief co-meteorologist at WeatherBell upon its founding. He's going to discuss how oceans affect the temperatures. We've got these little things on the Earth, actually not little, they dominate the Earth. The vast majority of the Earth is ocean, and these cycles of the oceans affect temperatures. Imagine that. So before we start, one housekeeping note. I'm going to be a harsh taskmaster. I'm going to keep our speakers on time. We're going to watch the time. We're going to tell them when they've got a few minutes left, and then I'm going to cut them off if they go over more than 30 seconds or so in their talks. Not pleasant, but we got to stay on schedule. I'm also going to be a harsh taskmaster with you folks. At the end, we should have plenty of time for questions. We want to get through as many questions as possible. So we'll have a monitor. I don't see her in the room right now, but we will have a monitor. They will have a microphone. I will recognize you for a question. When she gets there, stand up, identify yourself, and ask a question. One question. No follow-ups and no statements. Because we're going to go to the next question real quick. If I get statements, and if you go, oh, well, but what about, no, a question. We want to give everyone a chance. That's all I have to say. Anthony, take it away.
All righty. Well, thanks for that introduction, Sterling. Those of you that are in here in the audience, how many of you have seen the new weather station that's near the doors to the entrance to breakfast this morning? Just a few? A few, more than a few? All right, if you haven't seen it, please stop by and take a look at it because I'm going to talk about it during this presentation. And this presentation is going to make a proposal that I think a lot of you will be very interested in. So here we are. You've known about this for years. I've been studying this for years. I did a news travel survey this summer, as Sterling mentioned. This is one of the worst ones. This one here in Sandpoint, Washington. Just unbelievable. This is at the airport. Radiators, anybody? Gosh. Anyway. So we published a new book about it, and we collated all of the different stations, did some simple data analysis, and bottom line is now the number from, when I did it in 2007, it was 89%. Now it's up to 96% of the stations we surveyed have issues like this. Not as bad, but many of them have just as bad or similar type problems. Of course, there's all these stations all over the United States. There's the Cooperative Observer Network. The Cooperative Observer Network is run by NOAA and administered by the National Weather Service, and it's been in place since around 1890 or so when the Weather Bureau was formed. And originally it was there for agriculture. Agriculture was the main original focus for the National, or the Weather Bureau back then, but it got co-opted. They started using these stations for a purpose for which they were not intended. And that's why they're so bad. They're not really climate stations. Now, each station has one of these or both of these types of instrument shelters. The Stevenson screen, which is highly problematic for maintenance issues because you have to keep it painted, you have to maintain the wood and so forth. And then there's the other device called the MMTS, which stands for Max-Min Temperature System. But I've heard from Weather Service personnel, and I kid you not, they call it the Mickey Mouse Temperature System. Because that's what they think about it. There was one of those, it went to the lowest bidder when it was designed. But both of these things have problems. They have problems with albedo, they get dirty, they heat up. They're too close to buildings, particularly the MMTS, because it needs a cable. So what we found is that in 96% of all these stations around the United States, the ones we sampled, they violate NOAA's own published 100-foot rule. You'd think they'd be able to keep the stations away from the encroachment, but the problem is they don't really have control over the land. NOAA, or National Weather Service, doesn't have control over what happens at these places. And a lot of these are in people's backyards as volunteer observers or at farms or whatever. And if that person decides they want to put in a new patio or a bunch of pavers or whatever, they'll just do it because they don't owe anything to the National Weather Service to be able to say, hey, can I put in a patio next to your thermometer? They just do it, and that's why this stuff happens. Of course, back in 2007, when I first started, this is one of the most famous pictures. This is the fire station in Marysville, California. And all of this used to be grass years and years ago, but they turned it into a parking lot, and then they added cell phone towers. The city said, hey, we can make some money. Well, those cell phone tower equipment sheds you see there on the right have air conditioners on it. And I can remember vividly standing there next to the MMTS with hot air blowing on me from these air conditioners. And I said to myself, this is where they're measuring climate? Fortunately, a few months after I exposed this, NWS quietly closed this station. Same thing with Arizona, Tucson, Arizona. At the University of Arizona in Tucson, at the meteorology department. Those doors you see at the top, that's the meteorology department. And they put their Stevenson screen in the parking lot. You'd think atmospheric scientists would know better. Well, the story is that it used to be sited over grass a long time ago, just like all of these things. But the problem is the university kept building things, and they kept having to move the station. And then they finally decided, you know what, we've got nowhere else to put it, so we'll put it in the parking lot out front. Well, that station was closed a few months after I exposed it. So in 2023, or 2022, I started looking for more of them. Here's one in Wheatland, California. Anyway, this particular station, right next to the rooftop there, you can see the infrared. And is this a good place to site a station next to a parking lot and a roof? No, probably not. But it's been there a couple of decades. Here's one in Idaho. This one really floored me because Arco is a very rural community. I mean, literally, it is in the middle of nowhere. But they decided, hey, let's put it next to this brick building and this car. Works for me. This one here is the most egregious one I've ever seen because it was done by design. The MMTS that you see there circled on the left is above this rock wall. And this was just created a couple of years ago. They used to have the thing over grass, but they put it there. And of course, the rock wall is absorbing all of that infrared or solar radiation, all that, and converting it to long wave, and then at night it radiates it out and it heats up the sensor. And it rises. It's like the perfect place to bias a station. Here's another one. This one in Grants Pass, Oregon. Now this one was malicious, and I say this because the Weather Service knew about it. The chief engineer at this station I know personally. And he had years ago complained to the National Weather Service that where you put this is wrong. Can we move it, please? And they refused. I kid you not, and that's why I call it malicious siting. And of course, here's Sandpoint, Idaho. It used to be where you see this equipment on the left, but they moved it to this parking lot over at the airport. And the reason for that is that the Agricultural Experiment Station, which had been running this for years over on the left, they closed. But they had to have a physical person to take the measurements off the MMTS system, write them down, and send them into NOAA. So they put it over at the fixed base operator at the airport because there was a live person there. Simple as that. All right, so we're going to talk a little bit about science. The science of these heat sinks is pretty simple, really. In the daytime, a concrete object like that slab that you see there absorbs the solar radiation. It heats up. Anyone knows this. Stuff gets hot during the day. And at night, it re-radiates that as infrared. And that warms the air near the surface, which then, of course, biases the low temperature upwards. And because the low temperature is biased upwards, that changes the average temperature between the high and low, also upwards. And as a result, because that's used to track climate change, that is what gets biased. And that's why we see this problem all over the United States. There's an example, a perfect example. This is in Fayetteville, North Carolina. MMTS is right over a piece of concrete. You can see that infrared radiating right off of that thing. So when we look at all of the good stations, the ones that have not been compromised, and literally there's just a handful left, we're just about 125 or so, versus the bad stations that are all corrupted, the ones that are next to concrete and so forth. The blue line represents the good stations, and the orange and red lines represent different variations of the bad stations. Basically, the rate of global warming is halved when you look at just the good stations. Makes sense, right? So, what do we do about this? I've been pondering this for years, and I finally decided we have the power to change this. NOAA's not going to go out and fix all their stations. I've already tried this. They'll fix the worst ones that are embarrassing, but they generally don't care. They say, oh, we can statistically adjust this. You can't. No one knew about this. Back in 1998, they said, we need a better network. And then they had a paper about it. And then they commissioned a design for a new station, and the U.S. Climate Reference Network was born. It went into operation in 2005, and it's been producing data ever since. However, they say, of course, we can adjust for these problems associated with the bad stations. They can't. And all these adjustments do, homogenization, is when you get 96% of them corrupted, is smear the bad data around and cover up the good data. You bias the good data warmer. That's the problem. And they don't talk about the Climate Reference Network, the new state-of-the-art network, in any of their public reports. And meanwhile, it hides in the background. The public is virtually unaware of the good data and what it says. Here is a comparison of US CRN data on the left, the good data produced by this new network, versus NASA GISS over on the right. And I'm sorry these aren't to scale, but you can see that NASA GISS is reporting a significant upward trend, whereas the same period over on the left, it's flat, virtually. There may be a slight trend, but nothing like what GISS is doing. And GISS is using all of the bad data. So the idea here, circumvent them by creating an independent network, and that's what that weather station is about. Place stations to get clean, independent data, open architecture, and open access. No need for the government anymore. The government controls all of the climate data. We need an independent set. No need for the data adjustments, trustable temperature data, monthly publications of this data, and open to the public. So, the USCRN is old technology, and the weather instrument technology has advanced dramatically. The costs are much lower today. The station I designed out there to meet and exceed USCRN, $2,000 versus $30,000. So I am introducing the Global Openest Atmospheric Temperature System. GOATS. Why? Well, it's going to get NOAA's GOAT. That's why. It's literally. So here is the USCRN station on the left and my station on the right. And these will have the same kind of features. They'll be well-sighted, triple redundant temperature sensors, fan aspirated shields, and the accuracy is equivalent, 1/10 of a degree centigrade. And the interesting thing is that NOAA, with the co-op network, they round up all the temperatures to the nearest degree Fahrenheit and then convert them. So there's precision loss and everything else going on. So it's going to be better than NOAA, or at least as good in many cases. It's going to be reporting data every 1 minute with a 10-minute average. And the reason for this is because back in the day when mercury thermometers were there, they were not responding instantaneously to high temperatures. It took them time to warm up. So a lot of the problems that we've got with the new temperature data set from electronic sensors had to do with the fact that if the temperature goes up briefly, for a couple of seconds, Those sensors can detect that, and so we get an artificial high compared to what was measured in the past. They're solar-powered, cellular data reporting, and going out to the cloud. And they've got GPS, so if someone tries to steal them, we know where they're going. Plus, we know where they are sighted accurately. And this is what it looks like, and it's got two-way communications. It's got a data logger box that goes out to the cloud, you can get the data. It has the ability to add sensors. It'll start with just simply temperature sensors and maybe a carbon dioxide sensor, but we can add all of the stuff that NOAA uses for the USCRN. So it's open access, reasonable cost, plug and play. If you can set up a home stereo system, you can set up one of these. One person, all is needed. Don't need a contractor, don't need to pour concrete for a base, none of that stuff. And it is deployable worldwide. Well, placement, we'll make sure that these are placed properly. We'll look at Google Earth and so forth. We have a robust system. It'll operate several days in full darkness with the solar panel and battery. We've got maintenance taken care of, and ongoing costs are small, $50 a month or less. And we've got built-in security. All of the things necessary to make this happen. This is a screen capture from a couple of minutes ago of what the data output looks like. And as you can see there, we've got the 3 probes. We've got humidity, and we've got carbon dioxide. And the 3 probes data is automatically averaged. This will go into a cloud database, open access. Anyone can get it for any data analysis they wish. Go prove it's wrong if you can. Thank you. We do need sponsors. I want to say, if any of you want to step up and help us out here, one of these stations costs $2,000, and I will be happy to put your name on it as sponsored by. Thanks for your consideration.
All right. Good morning, everyone. I just hope that my slides is up, please. In any case, I want to talk about following what Anthony has said. Excuse me, is my slide on? Okay, thank you. Yeah. I'll be speaking on global warming and what do they mean by global warming as using all the thermometer data that is somewhat not good. And then we will try to explain whether the interpretation of this warming is either mostly human caused or mostly natural. Which one is it, right? And my name is Willie Soon. I'm a scientist at series-science.com. Before I start, I want to acknowledge my 2 colleagues from Ireland, Dr. Ronan and Michael Connolly, for helping me put together this slide set. First thing is about IPCC, obviously, right? They make a lot of claims. But as you can imagine, from 1 to 5, right? Global warming is there, is warmed by 1.5 C or 3 degrees Fahrenheit, so on and so forth, and it cannot be explained by the sun, so on and so forth. And then, but the obvious one is basically claiming that the contamination of the thermometer data, let's say by urban heat island effect, is less than 10%. Those things are open to challenge, and you can prove them wrong by just even turn around. I mean, that's how simple it is, and that's why it's embarrassing for IPCC to make that kind of claim. But this is how they try to tell everyone that, you know, if you look at the data set, right, the solid line is the observed temperature record. Never mind what it is, we'll explain later. And then they say that if I were to try to simulate in computer climate model using only volcano and the sun, which is the green lines, well, it won't fit. If we add CO2, it fit. Problem solved. Everything's done, so let's all go home and stop the funding, right? So I'm going to talk about this subject matter. It's quite a lot to cover in 20 minutes, obviously, but then I hope you understand that you don't have to rush, and somehow the website doesn't appear, but please, you can get all the slides at series-sign.com/post/ICCC15, okay? And we will actually speak about all these issues and clearly shows that IPCC is beyond, good standard of science. The first stage is I want to talk about the history of how global land temperature is constructed. There are 6 stages. The first stage is basically the simple stage from Vladimir Köppen and Edward Bruckner and even Homer Clue from US Weather Service, asking a very simple question. Does the globe the climate change? I mean, the answer is obvious. Climate does changes, right? And then second stage is very clear, is in 1930s to 1940s. There are folks like Joseph Kinser, actually also from US Weather Service. They clearly started to collect all this data worldwide based on the Smithsonian weather records. And they found that, the globe seems to be warming. And then there are guys from England named Guy Callender. By the way, he's Canadian also. And he realized that, wow, this could be all blamed by rising of carbon dioxide. And then there are third stage, which is 1940 to 1970s, right? Global cooling, basically. They realized that the warming that they observed earlier didn't continue. The globe appears to be cooling slightly, right? And you can see that one of the effects of the temperature record is basically, by now, a lot of things has been gone into this mix. They've been adjusting and readjusting, and then somehow the cooling part seems to disappear a bit, right? We will explain exactly in details after that what happened. And then fourth stage is basically global warming is finally here. Let's stop mincing words, and then greenhouse effect is here. This is, of course, the testimony of James Hansen in the hot summer of June 1988, right? Everyone got panicked. IPCC got formed. The world appears to be very, very scared now about this temperature warming that is only like 1 degree, 2 degrees Celsius. I mean, boom, that's 10 degrees right there, hot. Fifth stage. War against climate skeptics, obviously. They say, well, urbanization bias is not a problem at all. The raw data is not reliable, so we must homogenize them. We must adjust them in some way. And then, of course, there's no hiatus in global warming. This is a topic that's been gone over many times in this conference. And then, of course, it ended in a very clear situation where we see a lot of manipulation going on. It's called climate gate. Look it up, of course. If you want, we can discuss this later. But sixth stage, science is settled, guys. No more challenge, no more ability to even ask a simple question, how good are the thermometer records? That's what we will do today, by the way. The only reason why I stand up here is that we work very hard. This is a cumulative experience of at least 50 years of learning. Trying to tell you that you can take this message, take this slide, go and talk to everyone, your neighbor. First of all, start with your family, right? Your children, your grandchildren, and tell them, explain to them why this global warming thing is not so clear in that sense. So, how reliable are the raw station record? Anthony has shown you a lot of good example, right? Changes in instrumentation, how you measure them. The obvious one is this step change. There are two types of changes that I think worth discussing. Step change, which is one-time change that have nothing to do with climate, but temperature started to warm or cool, right? And then you have trend biases, more systematic type, like slowly building up of an urban city, right? And those are the effects that is much harder to correct for. But we will start with the step biases. This is one of the examples from Austria, right? Münster station in Austria. It's actually a rural station. From the 1767 until now, they actually have a record that measure outside the window, right? It's about 7 meters up. And then 1980, they moved down to 2.2 meters on the ground. They used the Stevenson screen station that Anthony was criticizing just now. And then you can look at this data. The data from the earlier period was there, and then boom, right? They measure from the old way, and then the new way, temperature start warming up. Those things really need to be corrected if we want to study them correctly. So they are right in some sense that we do have to correct for the raw data, but one has to do it very carefully. Of course, the good system that Anthony just discussed could be also very useful. And then the well-known effect of urban heat island effect. This is very well-known. In the inner city, it's much, much warmer than outside, okay? And indeed, this is a human-caused kind of climate change, really. But it's a local change, has nothing to do with rising carbon dioxide in a sense, right? And this phenomenon of urban heat island has been well known by the English meteorologist by the name of Luke Howard in 1820s. He already realized in the phenomenon in London, right, versus outskirts of London. And then this is one of the prime examples. You can see on your left, it's basically Paris and then Singapore. The temperature change there from inner city to the outskirts is up to 5°C, okay? This is way beyond any global warming signal that you are looking for. And then my two colleagues, Ronan and Michael Connolly, in 2014, many people have done this, by the way, but they are the one that independently do this work. Look at what they call GHCN, which is the Global Historical Climatology Network, right? That is collected by NOAA, looking at the version 3 data. And then looking into US, which has the most stations, 1,200 of them. Separate them into you know, the rural station, and then the intermediate and the most urban one. And then compare them. Here's what happened. At the top graph, you will see is the urban station, and then middle is basically the rural. If you subtract the two, you can see the net warming trend of 0.5 degree per century. That's a lot. For those who know this kind of graph, this data set already correct for the non-climatic bias called the time of observation bias. If you don't correct for that, it's actually 0.7 C. Okay, it's a huge per century. That's a big signal. And then one example that they know very well, my two colleagues from Ireland, so Valencia Observatory. In 1867 to 1892, those measurements were way out in the Valencia Island, off the coast of Ireland, right? And then in 1892 to 2001, they moved slightly inland, and then by 2001, they moved all the way 350 meter inland, and then the elevation was up 20 meter higher. So clearly that we have good station history. I want to promote that we need to have that information, okay? And from here, you can see the 4 major changes during this time period. And a lot of them needs to worry about, we need to have a full record of this. So my colleague collected all this data. So we started to propose the idea that why don't we start looking at the rural station? We started to propose something like construct rural island, rural US, rural China, rural Arctic, for example. So that's what we're trying to do here. This is the example of Ireland. And then you can see on your left is the island, and then the US rural station. The US station got the most data, so the trend really don't look like the global warming signal that you see. Rural China, and then also Arctic. Arctic is much harder. We search very deep. For 4 years, we look for any station history data that is available. No one was wanting to give us or work with us and so on and so forth, but we have success in Europe, so we'll tell you that in a minute. And these are all the stations that we have collected. So what we do is that let's average them and look at what they look like. At the top panel, you can see is the rural station over Northern Hemisphere. Okay, it's completely slightly different trend and structure, as you can see. But if you add urban station to this particular 4 region, guess what happened? You got a warming trend that look very similar to the IPCC kind of curve. Okay, and then here on your left again, we take all the GACN data and average them to show you that you get this signal that very similar to IPCC proposed. And what we're trying to propose is that, look, let's consider the rural station only data. And you can see even from this simple exercise, you already proved beyond doubt that the IPCC claim that the urban heat island effects is less than 10% is completely wrong. It's at least 40% right here, okay, from this estimate. And then this is what I mean. Can we actually recover what they estimate? We put some 5 or 6 group of what you call construction of the rural and urban station. This is where the part of the tricks. When they construct this station, they put all of them together, and then you show this warming trend that is very clear, and then we can recover the same signal. What we're asking them, can we look at the rural only station, right? So quickly, if we compare these 2 data sets with, let's say, oceans and climate proxy, what happened? This is actually the ocean data. This is the 3-ring proxy. This is another proxy from the glacial length. You can see even from this result, by the way, it's quite interesting to show this result. No one even plotted this out before us. In some sense, it's kind of weird, isn't it, right? But it shows you that actually there are some problem in the thermometer record that they are proposing. So I want to quickly update GHCN, version 3 to version 4, right? And we have, I believe, been working on version 4. Version 4 is not completely dead yet. By the way, the problem still persists. No station history metadata available. But we found a colleague, Peter O'Neill from Ireland, that was able to work with us, and when we already published paper talking about all this problem in the thermometer data. So GHCN data is also similar to GHCN 4, but then a lot more data. They have about 20 to 30,000 more stations. GSCN version 3 is only 7,000 stations, right? But most of the stations are really in the northern hemisphere. There's no data at all from southern hemisphere. And here's one example of what the NOAA results are showing. This is a paper published by NOAA group. The first thing we want to start is the version 3 with the urban and rural, non-homogenized, unmolested. So they show this temperature curve that looks quite interesting. It's warming straight. And then if you study, well, this is the endpoint, it's important to point out. And then if you were to study the effect, right, of changing from version 3 to version 4, what happened? A lot more station, far a lot more station, the modern period warmer than the version 3. Version 4 is slightly warmer. And then the past cool, okay? So it looked even steeper. And then very quickly, if you look at the effect from without homogenization, the version 3 to version 4, there's much smaller effect. But the main effect here is basically after you homogenize them, version 3 and version 4 look virtually identical, okay? It shows you the effect of homogenization, and it will explain the problem. There are two problems that we will show very quickly. So now, surprisingly, indeed, from version 3 and version 4 is not important at all. Even if you add like 15,000 more stations, it doesn't make any difference, right? From the averaging. But why does the homogenization add warming? That's the key question. And we want to explain this problem, of course. It's called urban blending, so we'll come to that in a minute. But IPCC, NOAA, GIS, and England, they've been promoting this. We must only use the homogenized data, okay? Which is really not a good idea, actually. That's what we want to propose in this talk. So give a quick example of what happened. This is what we did. We actually systematically look at the station history, correct for it as accurate as we can, according to the recorded history. Here's what we found out. This is the first paper we published in 2015. Remember, it's already 8 years, okay? We found out that every time they change this data, homogenize, update the data, every time the recommendation adjustment changes. So 5 or 6 examples here. That is something very fishy, isn't it? Because every time you change, it should be the same. You shouldn't change the record. This is something very suspicious, and we already published this and talked to all those people, tell them to do it. Nobody do anything about it, obviously. Like Anthony said, they don't really care, right? So we need a larger sample. So we studied that one for Ireland, the Valencia Observatory. So now we meet Peter O'Neill. Thank God for Peter O'Neill. You know what happened to Peter O'Neill? He collected a lot of version of their update. Every time they update the GSCN version 3, version 4, he collected. Every month, he have one data set. This is the amount of data that he has, version that he have collected. For version 3, he have almost 1,900 of them. You understand how important this is? I mean, don't even keep them. We have them all. And then 1,800 of them, we got this for version 4. Look at what happened. We are able to publish a paper last year with the whole group of meteorologists from Europe. So Europe, we started to see how much station history we can get. Okay, so this is a very interesting paper. And here the red dot showing the station where we have meta station history. 259 for version 3, 850 for version 4. By the way, it's only 20 to 30% of the total available station. It tells you that we're not able to do this big analysis yet. But the whole point is that we're beginning to have some hope here. So you ask a very simple question. How well is the adjustment? It's only 17% of this adjustment make any sense at all. It's applied consistently. And then if you check the adjustment according to the station history, because we have them, we can show that less than 20% of them agree with actual history, because the rest of it is artificial. It's all nonsense. That's why we want to tell you that we have worked on this problem. It's called urban blending problem that is very, very serious, okay? Please look for a minute. This is a very important problem that no one even talk about. No one obviously want to run away from all this problem. To start that, I want to illustrate this simple example. Remember, take a deep breath. You can actually get this slide and study for yourself, but I want to quickly go over this. Imagine this pure world that no global warming, only urban warming. Station 1, we have a station that have moderately warming, no bias, no other bias. Station B is rural, have a step change. Station C is basically similar as Station A, but then it has a cooling bias, okay, in a step jump in 1985. Station 4, very heavily urbanized, like Station C, but then more urbanized. It has a step change. So you look at this step 1. What they do is that they compare, let's say that we want to homogenize everything according to Station A, okay, that is slightly urbanized, right? And then you can see, you compute the difference, and then you can quickly apply the adjustment. This is what happened, the end result. But the question is that, is this correct? We want to illustrate the example that, look at the Station B, which is a very clear example. If you correct this thing correctly, it should be no warming trend at all, because it has no warming. It has only a slight shift in the cooling. If you should do that. But because you mix it with other stuff, you actually have a warming trend of 0.7 degree, which is really large. It's true, the most urbanized one on the right-hand side, Station D, is showing that the most warming trend from 3 degree is reduced to 2.2. Okay, that's a very interesting, but people keep forgetting the more important problem is the contamination of the rural station. And this is what happened in consequence of urban blending. They are drinking too much smoothie, strawberry and banana smoothie, and they forgot that, you can never get the banana flavor back and the strawberry flavor back. And that's the problem of homogenization data. So please, tell people about this problem. Urban blending is a very serious problem. And here, real-world example, in Beijing, 10 station, published by He and Jia in 2012, and we reported this back in 2018 in our paper, that we show you, if you quantify these 10 stations according to the degree of urbanization bias, very, very urbanized, very, very high warming trend. Less urbanized, low warming trend, okay? And then if you correct for the homogenization, look what happened. The most urban one gets slightly cooler, less warming trend, but it's the the rural one all get warmer. This is the contamination process. Again, this is not talk. This is proof that they have problem, and they should admit this problem, isn't it? So what should be done instead? There are a lot of proposals. By the way, we wrote words after word. We published quite a few papers now, and of course, they keep ignoring it. But in the meantime, I want to propose us to look at rural Northern Hemisphere, which is more climatically representative to study the cause, okay? And then we got to study this based on, instead of homogenized rural and urban. Again, remember this curve? We know now the reason why their curve is kind of not good is that because its observed temperature curve is contaminated by urban heat island effect and urban blending, isn't it? But when they run the model, do they get the sun correct, actually? I want to propose to you, obviously it's not correct. This is what happened. This is the basic and embarrassment of solar physics. My apologies to all my colleagues. We've been working for this for at least 30 to 40 years now, right? This is the direct measurement from satellite. You put a radiometer up there, you try to measure how much the light output has changed. Just the absolute scale, the difference between the 10 or so measurements that I put here is from 1360 to 1372 watt per meter square. That's a difference of 12 watt per meter square. Doubling of CO2 gives you 4 watt per meter square. It tells you that this problem is not resolved and a serious problem. And the question is this: how do you combine them together? This is what happened that you can do this. You can have 3 options at least that we can think of. The first option on the left is promoted by IPCC. It's called the PMOD, the Swiss group. And the middle one is actually the Royal Meteorological Institute of Belgium. And the right-hand side is called the ACRIM. Each of them will have consequence, depends on which one you pick and how you combine them. Here's the example. You have cooling, and then you get slightly interesting. Almost there, don't worry about it. I'm cool. And then now, here's the thing, right? You look at what IPCC say. They use urban and rural station, and then they use the PMOD data. Obviously, they're right, isn't it? Can we give a round of applause? IPCC win. Now, let's go to ours. Let's propose the rural only. Let's use the cream calibration. Look what happened. Can they say that they rule this out scientifically? I'm sorry, it's nonsense. Goodbye, IPCC. I mean, here's the problem. So very quickly, I only tell you 2 papers out of the 17 papers we published so far from Series Science. Sorry, a little bit promotion of Series Science, okay? Our first paper by Series Science was actually cited by IPCC AR6 in 2021. They claim that we agree with them. So it's an embarrassment for them. Of course, we can easily point out that it's wrong. We actually was evaluating the northern hemisphere snow cover changes. We found that all 4 of them are disagreeing with the climate model, and they say that we agree with them on 2. That's what they're trying to do. They cover up the other 2, which is really not right. And then, just quickly, a plug. Look, halftime. IPCC score 1. Even when we're playing on this slanted field, we score a goal myself, right? Actually, Ronan did it, not me. But we were playing defense all the time. This is the problem. And science has been so bad. If you learn anything, please look at the slide as series.science.com/post/ICCC15. Our funding really comes from people from you to donate and don't tell us what to do, actually. If you trust me, you give me $10 or $100, you'll be helping science, not helping Anthony Fauci. I won't send the money to Anthony Fauci. So thank you very much for your attention, and yeah, please help science, and please help support Heartland Institute also. Thank you.
Well, I was afraid that was going to happen. I'd have to follow Willie. And now, the first thing I want to say about, it's funny, we got Anthony and Willie here. They're talking about thermometers. My dad went to A&M, and as a matter of fact, one of his classmates is here today. But my dad's first job was in OBS and Method Research Meteorology at Atlantic City's FAA Tech Center, right? And so in July of 1969, Atlantic City recorded on the 19th or 20th, recorded the highest temperature in the country at 106, which was very interesting since no one within 150 miles of Atlantic City was over 100 that day, and the wind's roaring in out of the south, that, you know, even at the airport 14 miles inland, the sea breeze gets in. Well, what happened was, Dad comes home, he goes, there's no way it was 106 today. I mean, you know, we're sitting there in the low 80s in Summers Point. So you know what he did? He went out there with 5 thermometers, and he found out that the Atlantic City thermometer, while it was fine at 32 degrees, because they used to put the thermometers in ice baths and measure them at 32, the error of the thermometer was increasing as it got warmer. So it was 94 degrees, reading 106, and that record still stands today. They won't change the darn record. And I was in instrumentation at Penn State, and I have permanent scars from that class. I'll tell you that right now. So all this stuff gets kind of spooky. Now, the title of this is, I don't have the answers, but I got some questions. It's sort of like, you know, the Festivus thing where Frank Costanza comes out, I got some problems with you people, and now you're going to hear about it. Not with you people, but other situations here. So I got to move the slide here along. Anybody know how to go forward? There we are. You know, it's kind of funny in science. There's two biblical references to me that describe science. Proverbs 25:2 is glory of God to conceal the matter, search the matter out, glory of kings. And then Paul, the Apostle Paul, said, those who know what they know don't yet know what they ought to know, all right? And so what happens is the more you discover, the more you go, holy smokes, I don't really know much. and it has to do with the infinite majesty of the universe. So this was a very interesting situation. This lady, Rebecca Carey, she was a volcanologist at the University of Tasmania. In 2012, she said 75% of volcanoes occur underwater. We know nothing about it. Now that got me thinking, because one of my professors at Penn State, Dr. John Kerr, said, we don't know anything about the oceans. We know virtually nothing. We're not even looking at them, really. All we're looking at is what we see in front of us rather than what might be concealed. So we're in a climate optimum, not an emergency. Quite frankly, it's amazing. It's great to get together at these conferences, but the left these people have actually pushed something that is nonsense and made it, they've taken over the entire idea of the thing. And this is no big deal. What's going on, the warming. I wish it was a big deal, because then it would really make me more important, but it's really not. And we have 4 times the amount of people on the planet than 1930, and 1/28 the amount of climate deaths. So what I want to know is, if we are in a climate optimum, and obviously life is getting better on Earth, how is this such an emergency? Well, life's never been better on planet Earth, so that's all I've got to say, and thanks for coming. I'm only kidding. When your name ends in a vowel, you don't throw in the towel. First of all, got Morano. Is Morano in here? Temperatures, and this is from the book of Care, John, Penn State. Temperatures are a poor climate metric. Wet bulbs are better. The best are saturation mixing ratios. They refuse to quantify that. Because, I'm going to explain in just a moment. We'll keep moving on. This is correlation of saturation mixing ratio to temperatures. What it says is this, that the increase in 1/10 of a gram per kilogram of water vapor in the air correlates to a 10-degree rise in temperatures where it's very, very, very cold, -40 to -30. You need 90 times the amount of water vapor to do that, where it's 75, 80 degrees. So if there's excess water vapor in the air, where do you think the warming is going to show up? So it shows up in the Arctic, right? And I've befriended Dr. Arthur Vitorino, and what happened was, look, here's the problem I have. And what I do for a living, what is going on in the ocean is very, very important to feedback in the atmosphere. All right, and the Mann-Julian oscillation, for instance, you can watch it oscillate based on the sea surface temperatures and the convergence patterns that go on. It releases all sorts of heat into the atmosphere, bang, it sets ridges up in certain places, troughs up in certain places. So we have to know what's going on. So I'm looking at the sea surface temperatures, and from the 80s to now, they're just warming up. And I'm saying, well, what the heck is causing this? We all agree it's not CO2, right? Not CO2. The sun, I'm going to show you a graphic from Dr. Soon. You could see the water vapor increase moving with the TSI, okay? But you also see something that's happened since the 80s, that there's been an increase in seismic activity, and no one wants to look at this, all right? If you get a big earthquake that goes off or a big volcano, oh, look at this, but most of the activity is going on underwater. So I'm going to go through this real quick. There's a diagram of thermohaline circulation. I hate to tell Michael Mann, but guess what? It's not CO2 that's causing all the warming in the North Atlantic. He won't look. Pretty good argument for correlation and causation in this particular case. This is the increase in seismic activity and the temperature going up. And that puts water vapor in the air, so the warming is distorted. It's more in the Arctic than it is anywhere else. Now, it's interesting. Greg yesterday pointed out what's going on in Antarctica, that the melting of the Antarctic ice cap is below. And see, I said, well, bingo. Well, when I look at these temperatures off New Zealand, the sea surface temperatures off New Zealand, and what's going on in the North Pacific, I'm like, well, what the heck? Why aren't we trying to observe what's going on there instead of just we could see it in Antarctica because we got more saturation of data down there, and yeah, I don't know if it's a coincidence. Is it? There's the increase in seismic activity, and it correlates nicely with the increase in sea surface temperatures. Again, if you increase the temperature of the ocean, you put more water vapor in the air. We know the relationship of water vapor to temperature. You know how you can figure out what CO2 has done? If you could, and this is what drives me crazy about my field. All you need to do is try your very, very, very best to approximate the water vapor transport into the air from, let's say, the sea surface temperatures in 1983 versus now. All right? Because there's no one, when you look at these temperatures, if you had the sea surface temperatures you had in the 70s and 80s, no way is it warming up the way it is. And so whatever minute warming there is, that may be your man-made warming or whatever they want to call it today. Now look at this. All right. This is the oceans in 1988, and the first big increase of seismic activity began in 85. But look at how cold the sea surface temperatures are in 1988. And look at the oceans now. You're not even looking at the same thing. As far as the transport of energy from the oceans into the atmosphere, this is remarkable. And by the way, apparently there's a CO2 ferry that I don't know about in the southern hemisphere and in the northern hemisphere that says, I bequeath a hot spot here and a hot spot there and a hot spot there. Look at the hot spots in there. Where the heck are they coming from? So the oceans they're warming up. And what happens is, you see the atmosphere, Le Chatelier's principle, you see the atmosphere fight back, try to even it out. But every time it cools, it leaves the base temperature of the ocean a little bit warmer. So we got to figure out what the heck is going on here, all right? Again, I don't have the answers. But if you tell me it's not CO2, right, we all agree on that. If you eliminate some of these other things, there must be something causing this to happen. So these hot spots are very important in the forecast. Now watch this. This is from Joe DeLeo at weatherbell.com, all right? He points out the hot spot in the North Pacific, and it argues for western and central cold in February and March. He said, well, it's been awfully warm in February. Oh, wait till March is done, right? It's like the revenge of winter is coming for much of the United States, including people in the Northeast. It's almost like the hurricane season, remember? At the end of August, oh, nothing's going on, blah, 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 blah. And look what happens, right? You can see the atmosphere setting things up. So each of these areas, what Joe does is he looks at certain sea surface temperatures in certain areas, and he correlates the temperatures over the United States, right? The problem is that when we talk about this, when we make our seasonal forecast, I go, well, Joe, I don't think you could use 1978 with today because there's a completely different now I'm not going to say completely different, but the feedback is a bit different today. So February, March come out like this, so you say, oh, wait a minute. It's been warm in the central part of the United States. Like I said before, you know, we've got a tremendous stratospheric warming event going on now, right? And the last 2 times that happened, beautifully correlated, 84 and 2018, the blend of those two will come out to that. So if the oceans had not warmed, the air would not have warmed significantly. The oceans and more water vapor in the atmosphere, so warming is more in colder, drier areas in the winter season. It distorts the warming, changes the feedback. Now, Willie Soon got me thinking, because he and the Connollys have taken a lot of balloon measurements, and the Hadley cell is collapsing, which would make sense if you have distorted warming. Why? Because if there's more upward motion further north, what's that going to do to the Hadley cell? This is big in meteorology. It's also, by the way, not a sign that the planet's going to blow up. It's a sign that the natural fight back of the atmosphere to the warming that is occurring, that nature's fighting back. It has major implications, all right? More water, blah, blah, blah. I'm just going to go through this real quick. It influences everything. Hurricanes are developing further north, but they are smaller in size. We got to get rid of the Saffir-Simpson scale. I've been proposing a power and impact scale that measures the radius also of gale force winds, 34, 50, and 64 knot winds. Not this, oh, well, right near the center, you've got 125 mile an hour winds as a category 4, right? I'm like, well, wait a minute. Harvey, which hit Texas, and of course it stalled and they had a lot of rain, but Harvey's radius of hurricane force winds was 150 miles. Carla's was 400 miles. How are they both category 4s? If Donna went through Florida today, if Donna from 1960 went through Florida category 4, you might have had $1 trillion of damage. That's how powerful Donna was. And Donna didn't screw around. She was still a 3 in North Carolina, a 2 up in New England. That's an unbelievable storm. So look at the Arctic. No warming in their warm season. Oh, isn't that interesting? It's only warming in the winter. Now, I wonder why that would happen. Well, part of the reason is that if the action of refreezing actually warms the atmosphere, melting actually cools it. But the amount of water vapor increase is not yet great enough to affect the temperature around 32 degrees. News flash to people claiming that the Arctic ice cap is missing. The average temperature around the Arctic is 32, 33 in the summertime. So if it's not getting much above freezing, guess what? That Arctic ice cap isn't disappearing. Now, you have to be ignorant, in my opinion, to spout what leftists do on climate migrants. How the heck is a generation or even 2 generations going to measure 0.1 C increase in temperatures in Central America, right? You see this, there's virtually no increase here. However, if you are a polar bear that wants to migrate south, you do notice it is warming up in the Arctic more. Another thing, John Kerry, remember Boko Haram? That's a major drought, and that's why we have a terrorist organization. Well, the reason why we've been having bigger hurricane seasons is because it's wet in Africa. Bill Gray used to talk about this, and it's been very, very wet in the areas where Boko Haram, not a drought. They just say stuff, and no one calls them on it. I'm just absolutely fascinated with this. The Pacific Ring of Fire, every time the La Nina shows up, you can see the sea surface temperatures remaining very, very warm. In fact, that area around New Zealand, I wish they'd do some research on that, because the sea surface temperatures are unbelievably warm there. Now watch this. 1951 through 1960, these are the sea surface temperature anomalies, skin surface temperatures, right? We go 1981 to 1990. Not much change, would you agree? See any change? But the most recent 10 years, it is warm. Now, why does that just happen all of a sudden? And believe me, when you look at the change in the anomalies over the North Pacific, this is a big, big deal for forecasters. Now, until the early 90s, the TSI was in lockstep with temperatures, right? But then the temperatures began to shoot up. So there's no change, there's sea surface temperatures, no change for 40 years, and then the jump. Here's TSI versus water vapor. I got this from doctors. How you can't beat that correlation, can you? All right. I would say. Now, this is seismic activity, underwater geothermal forcing versus temperatures. That's pretty darn good. Now, this is I steal from Dr. Spencer here. My argument on this water vapor is that every time a Super Nino goes off, an amazing amount of water vapor goes up into the air. When it spreads out, where do you see the warming? It's in the Arctic more, right? All right, so if we continue on here, CO2 versus temperature, if we're playing the correlation game, it has the least amount. You see what I'm saying? So I'm sitting here going, well, why aren't you looking at the other things? Why isn't my community, these young guys, I go, why do you just sit there and go along with it? Aren't you curious as to why it's happening? So TSI and seismic activity, stronger correlations in CO2. What's the cause? Let me move through this, okay? We can see the proof in the weather. Where and when it's warmer. Changes in sea level pressure and global wind oscillation, tropical cyclone changes. Let me go through this quick. Again, no warming in the Arctic during its summer season. That's a big key. All right. Now look at this. You guys, I'm sorry I get so fired up about this. It's like, this is what God made me to do, so I go crazy over it. Look at the sea level pressures over Southeast Asia and across the United States and in the Arctic in the last 10 years. Now look at those surface pressures, 76 and 85. You had high pressure all over the place. Now do you understand what that means as far as the global wind oscillation? All right, if you have lower pressures over Asia, Southeast Asia, it's creating stronger easterlies through the tropical Pacific, which tends to lead to more subsidence, sinking air over the tropical Pacific. Hence, the reason why that Hadley cell observation may be what it is. Change in the global wind oscillation. Sinking air relative to the normal vertical velocities over the tropics. The drying over the tropics, counter to the trapping hotspot idea. Remember, listen, if you trap heat in the Arctic, it's not that big a deal, all right? If you trap heat over the tropics, you're in a heap of trouble, boy, because what's going to happen is that's going to start feeding back like crazy. That goes against nature also. The warmer it gets, the tougher it is to get it warmer. It's much easier to just cut the feed out from under this, and all of a sudden, the temperature drops 0.5 degrees C across the planet, and people are starving. Shift in the size of storms, shift in the hurricane paths, the weakening of the Hadley cell, more increased solar radiation over tropical waters, more outgoing long radiation, which CO2 does use. You know what? If the oceans had not warmed, CO2 is not even a big deal. I don't think it's a big deal anyway, but CO2 feeds on the warming of the earth. It's not the CO2 warming the earth, it's the earth is getting warmer, so there's more outgoing long-wave radiation showing up. And you know what Anthony showed, 1 minute. I haven't told my jokes yet. What Anthony showed, those nighttime pictures, right? I could tell you horror stories about the Penn State sighting place with that stuff. Now look, real quick, West Pacific storms, 1959. Notice the track race east of the Philippines, right? This is 59. Look at the most recent year. They're further north. They're developing later. Even the hyper season, this is 1933 versus the 2020 season. All of them are developing in closer to the coast where, you know, the Irmas are becoming more and more rare. So I talked about replacing the Saffir-Simpson scale. Specific humidity, real quick, 1951 through 1960. This is 400 millibars. 1976 to 85, boom. Look what's going on. It's drying out. It's drying out and shifting west. There's no fingerprint as far as this trapping hotspot goes. There's 400. Do you realize how opposite this is? There's 400 millibar cooling over the tropics, and the stratosphere is warming up over the tropics. What does that mean? If the stratosphere expands, what happens to the troposphere underneath? It's actually cooling a little bit. We're starting to see that. It's distorted. There's distortion of the warming in the north. That changes a bunch of things, and it's also the sign the atmosphere is fighting back. So I'm done. I went over this before. The Hadley cell is weakening, and there's a reason for you set me off over there. So it's not CO2. My questions are raised based on observations, need to know. The hypothesis is formed based on a search for the unmoved mover behind this. So guess what? Let's say there is more seismic activity going on. We find it's heating up. Then we look, well, what the heck is causing that? Now, I happen to believe the sun and the pull of the sun and the moon and that's where the sun is the grand conductor of the entire orchestra. But in the meantime, I'm still trying to figure out who the lead soloist is right now. And it's important. And some of you meteorologists out here that are still forecasting, you got to figure out where the heck this is coming from, because it's a big, big deal as far as the feedback's concerned. All right, enjoy the weather. It's the only weather you got.
All right.
They'll be answering questions at the tables. They've each got speakers. Why don't you go ahead and pull yours over, Anthony? As I said, raise your hands. I will recognize you. She will deliver a microphone. Stand and identify yourself and ask one question. The gentleman right back there first. If you can, tell your question to a specific speaker.
Joe Bastardi. I'm Ken Hoppola, SEP. And what do you mean by TSI?
Total solar irradiance. Isn't that right?
Yes.
Thank you. He's the astrophysicist. Mongo just pawn in chess game of life. Blazing Saddles. No one knows that. Jeez. You too.
I'm Francis Menton, the Manhattan Contrarian. I think my question comes out of Dr. Soon's presentation, but it could be addressed to anybody. What you said with regard to the homogenization of the temperatures that somehow import these algorithms that our government weather people, data people, put into the temperatures to cool the past and raise the present. I think you used the term, they have a problem that they don't recognize. My question is this a problem they don't recognize, or is this an absolutely intentional effort to enhance the warming trend? And is it done by, who does it? It's done by how many people do these algorithms? Is it a small number of people? What are their names? And can we find out what the hell is going on here?
Thank you, Francis. You have a very sharp question. I do have to be a little bit more polite than usual since my two kids are here and my daughter is watching at home. Obviously, I'm sorry. I'm also one of those is no PC. Sorry, no PC. No political correctness. Yeah, I think they do know some of these problems and they just won't do nothing about this. So that's why I think we may need to start what Anthony Watts is proposing, but the problem is that we want data for 100 years or 200, sorry. So kids, please, shape up. Time for you guys to take over. You know, we need more kids, more students who wants to learn anything meaningful in life and do this. Yeah, there are a lot of names, but of course, I write it in my books, a little black book, and then I'll share with you. And anybody who wants to know, obviously, but let's not name them publicly here. Tom Carr, are you there? Plenty more, plenty more.
Thank you, gentlemen, for your excellent presentations. Steve Wilson-Mock of Reality News. I guess, Joe, this is more towards you. The HARP system that was developed by the U.S. military with the purpose of doing weather modification. How much are you aware of that, and what impact do you think it might have as far as being one of the unknown causes?
I don't know much about it. I do know Fidel Castro accused the United States of stalling a hurricane over his island in 1963, Flora, as a payback for what happened with the the Bay of Pigs or whatever. The only thing that I am advocating for now, and people just don't even like, I think we should be seeding these intensifying hurricanes that are coming to the coast, because I believe you can actually mitigate the strength of the hurricane if you can disrupt eye wall processes. And so that kind of modification, I think, is pretty good. There's all sorts of crazy things I've heard going on, like the state of Washington or Idaho was suing Washington because Washington was seeding clouds and meant it wouldn't rain in Idaho. So I don't like to mess with nature. And there's something else going on. These people putting particulate matter into the stratosphere. I'm like, what kind of lunacy is that? Except, of course, now we could shoot down the balloons so we can get away with that there. But I'm not into modifying anything that God has created. All right? I guess that's my answer.
Well, thank you.
If you believe in God. So.
I have a daughter who thinks that we're controlling the weather from a station in Alaska somewhere. So.
It's the mothership over top of the earth.
I have a question for Anthony. Anthony, is there a website or something for your new global open temperature system that we can refer to, and people can go there and see how it works and get interested in the program and try to kick in some money and buy one and install it somewhere?
Anthony, he was
There's not just yet. It's a work in progress. This is exceptionally new. I mean, literally, things are changing on a daily basis with this yet. So in the next few weeks, we will have a website where this will all be documented, and you'll be able to get this stuff, and it'll be more organized. I've been focusing on the technology and making the technology accurate, because the most important thing about this new temperature network is that it be unassailable, because they are going to attack it mercilessly. They will say, oh, your weather data, your temperature data is no good. Well, we're going to back it up with hard science, peer-reviewed papers, the works.
Hi, I'm Bob Bauman from the Right Climate Stuff. This is for Joe. One of the interesting things out of your talk was the rising sea level temperatures due to the volcanic activity under the seas. A lot of it occurring in New Zealand and Indonesia. From what I understand, the El Nino and La Nina effect that affect our weather patterns originate by ocean temperatures in that region. Is there a correlation there?
Well, first of all, let me just say something. I am not married to this idea. Like I said before, I got questions, right? And I'm trying to figure out, the biggest thing I'm trying to figure out is why the heck the rest of the meteorological community is just sitting there watching the sea surface temperatures, because it's tough to change the oceans. You understand that? You know, the old saying, the wheels of the gods grind slowly but fine. That's the oceans, all right? It's not like the air. You could drive around on a calm night and see how quick temperatures could change. So this is a question thing. I'm not married to this idea. But what I suspect is going on is that the base temperature of the oceans is warming up, which is and if you put more water vapor in the air, you are increasing feedback potential, all right? That does not mean that the weather is getting worse. As a matter of fact, total energy in the atmosphere may be increasing, but what we call zonal potential energy, the difference from north to south or south to north, depending on which hemisphere you are, is actually decreasing, which argues for less severe weather. Only if everything gets together, it can really fire up pretty quickly. We know that, okay? So I think that, and you know, we got an El Nino coming on. You can already see it. In fact, the heavy rains caused by the La Nina across Indonesia and north of Australia this year, very, very important to why the U.S. winter so far has been very warm in the east. We call it the Madden-Julian Oscillation. Has been stuck in phase 4 and 5, driving me out of my mind because I do like cold and snow. So what happens is that cooling water now, we've seen the Indian Ocean cool. It's cooled all the way into that area. Well, guess what? Southern Oscillation Index, bang, it's taken a huge hit. The dailies are down to like El Nino levels, -20, -25. and you're seeing the warming already start off South America. So there's this big thing that goes back and forth. But I will tell you this, the very action of this nature of warming actually favors more La Niñas than El Niños. The problem is when they come back, they can be very, very strong, and then you're going to see the global temperature go up again. So we're in a pause now off the Super Nino. I think Willie wants to say.
Willie wants to.
I want to add one small little data point to support what he's saying, but all I say is that, look, we need more data. But the most important signal that no one talks about is that we already know this about 5-10 years ago. If you look under Central Pacific, no coastal process, no nothing, there's no way you can get the sunlight into this region. It's about 2,000 meters down. You look at the Argo data around there. The Japanese group found that, guess what happened? It's changing in a seasonal way. That tells you something about the orbit, Sun-Earth orbit. It's not sun per se, right? It's the orbital motion of the Earth around the sun. So, intrinsic signal. In fact, if you look below, there is actually very active magmatic region. You know, that probably the pulsing of the thing is doing that. So we can see signal like that already, but of course we need to see it for the whole globe and different places. And all this hotspot, it's all known, it's been monitored in some way. Okay, cut it short because there are many more.
I do want to add that the hot spots are getting hotter. You know, it's something. The deserts are getting drier. You know, no, but they are. They're increasing, and every time the sea surface temperatures fight back, it's left a little bit warmer.
I'm Gene Sklazacek from the Free State of Florida. This question is for Anthony. You mentioned several times in your talk that 96% of the sites that you evaluated failed to meet the siting criteria. What percentage of all sites did you evaluate?
Well, we looked at all sites, so I'm not sure what your question's about.
Well, no,
You continue to say of the sites you evaluated, 96% failed. So there's some implication that you didn't evaluate other sites, and you could have only chosen those that were going to fail, is what someone might claim.
In the publication, we have both good sites and bad sites. So we looked at them all. And some of the, for example, agricultural experiment stations, one in northern Idaho I visited, was perfectly sited. Everything was great, but the majority of them were not.
Thank you.
We've got Samantha running here back and forth.
Walt Johnson, Exploration Geoconsultants. Would a lot of this climate hysteria go away if we only use the maximum temperatures and we don't have to average in the heat sinks?
I don't think it's going away because I don't really think it's a scientific argument anymore. I think it's a socio-political thing.
If it's not the warm temperature, it'll be the acidic ocean, it'll be the ball trees and all kinds of problems. These people will come up with something more, for sure. So please, I don't think so.
Bob Enlick from Las Cruces, New Mexico. This is for Anthony. Did you notice that NOAA has made the Climate Research Network data much harder to find? And if so, why?
Didn't get that.
He asked, have you noticed that NOAA has made climate research data much harder to find? And what is your response to that?
Did NOAA what?
NOAA making research data harder to find.
Oh, well, I don't think that they're making research data harder to find. I just think that they don't give any credence to it because the public probably wouldn't understand it. The US CRN data it's available publicly, but it's not well displayed. You have to know what you're looking for to go find it. So, and it's never mentioned in any of the reports. The thing that I think they are doing consciously is not bringing this data to the attention in their public reports. Their monthly and yearly climate reports are completely absent of this data. And so that's our goal here, to make this kind of data more visible. Because when someone says, for example, well, San Antonio hit a high of 105 today, if you look at the stations near that are on the periphery of that, you know, they might hit 98. This is never mentioned. And so what we're trying to do is illustrate the fact that UHI and siting problems are creating artificially high temperatures and also inflating the trend.
I'm gonna disagree just a little bit. Past data is disappearing. The wildfire data, they've just truncated it. You can't find the older data on their sites. If we hadn't saved it to certain sites, it'd be hard to find. They're doing that with several other things as well. So present data is not impossible to find, but if you look at the past data, where it's inconvenient, it seems to be disappearing.
Terry Ciccone, Sarasota, Florida. Question for Joe. Sometimes I get the opinion that the other side uses us and what we know against us to make their own cause. For example, why do we even indulge in all these trivial accuracies or lack of accuracies on CO2 levels? It doesn't cause climate change. End of discussion, move on. Same thing with the readings from the temperature stations. We know they're corrupt beyond recovery. We should just dismiss any discussions on the subject, throw the questions back in their face, and simply rely on more reliable satellite temperature. I think sometimes, you know, we're our own worst enemy.
Well, let me just say, there are many times I've said, you know, I wrote a couple of books, and I said, you know what, okay, I'm out of this, right? What bothers me is the lack of truth. You know, I don't like people spraying me with a garden hose and telling me it's raining. I'm saying that as nicely as possible. You have to understand something. You're speaking as a rational, objective human being wanting the truth. That's not what this is about. This is about a greater truth. In my opinion, I came to this conclusion about 2015. This is not about climate, not about science. You know, we love fighting these little tit-for-tat battles. It doesn't make a difference, all right? So it's actually freed me up to just say whatever I want to say a little bit more because I don't worry about repercussions. But what it is there is an agenda out there that somehow or the other that the United States of America and our system is bringing down the rest of the world, when in reality, you know, Barack Obama famously said, 4% of the people, 25% of the resources, right? Yeah, but look what we've done with them for the rest of the world, that the rest of the world is advanced because of our system. And there are people, they hate what's going on in the United States, and I believe they brainwashed a lot of people into looking at it that way. You can't talk to them, see? But I think you're exactly right. I mean, what are you supposed to do, though? Lay over? I don't even know what TikTok is. My daughter sets up my stuff.
Hi, this is Greg Goodnight, the Right Climate Stuff. This is for Anthony. I continue to be amazed how the 1930s continues to cool even today. Whenever NOAA comes out with their things, my question to you is this time of day adjustment. I understand there was presumed error in the time of day measurements, you know, the two measurements. Could you comment on the 1930s and why in the world does it continue to cool?
Well, can you restate your question because it doesn't quite make a lot of sense to me.
If you look at NOAA, the 2019 temperature records, what you see is the 30s, and the period that it was very hot, it came down in terms of temperature. And I was told it was a time of day adjustment where they presumed that the temperatures weren't taken properly during that period, and that was the rationale for the adjustment. So are you familiar with this?
Yeah, I've seen the cooling effect associated with homogenization. It tends this happens, it seems, everywhere. And it's a statistical fluke. The problem is that they're trying to create a temperature that represents a surface. And so they do this by combining these stations with the homogenization process, so they can say the temperature average of the United States was X. The problem is that the homogenization process itself corrupts the data, and the artifact is that it tends to cool the past. And they think that this is perfectly fine because in their mind, well, those temperatures must have been overestimated anyway. It's a confirmation bias type thing going on.
You ever wonder, real quick, you ever wonder how a Category 4 hurricane for 50 years suddenly got downgraded to a Category 3, Audrey? How the heck did that happen? What the people? Audrey was the strongest June hurricane on record. Hit 947 millibars, 140-mile-an-hour winds, southeast Texas Gulf Coast, Beaumont, Port Arthur. All of a sudden, well, wait a minute, that wasn't. It's down to a Category 3, and I suspect, I hate to say it, I suspect the reason is if some other strong June storm shows up, which is going to happen someday, they can say, see, Audrey wasn't the strongest. How does that get downgraded? By reanalysis. Where the heck did this stuff come from? So I believe in science and reanalysis, but stuff like that, Audrey's no longer a 4, it's a 3. How come it's always downgraded? By the way, you older folks in here, I know the weather was, you think it was bad when you were younger, but no, it wasn't.
Michael Justino, Cleveland, Ohio. For Anthony, you mentioned earlier about the 96% of the global temperature, United States global temperature. Okay, good. My question is, have you or anybody else looked at the rest of the stations throughout the world to correlate a percentage of the standard not being met?
Well, despite the fact that everyone thinks that I'm funded by ExxonMobil, I don't have that kind of travel budget. But I can tell you that we have done some spot checks of stations around the world and found similar problems. The biggest problem associated with finding these other stations around the world is that they're not well documented. NOAA, to its credit, has put together a fantastic database about where the stations are and their history. It's called the HOMR database, and it's a fantastic database. But there's nothing like that for the UK even, for example, or for South Africa or any place else. So a lot of the locations of these stations are a mystery in the sense of we can't go to a database and find an exact latitude and longitude as to where these are. There is a latitude and a longitude published for these things, but they're very coarse. And so, we have to look over, several square miles to try to find a little dot on Google Earth, and it's nearly impossible. But based on what we've seen, yes, the problem exists elsewhere.
This will be the last question.
Ian Plimer from Adelaide, Australia. A question to Joe. Why do you think the geophysical and geological data on heat flow has been totally ignored? We have more than 150 geothermal sites underneath the Antarctic ice, a large number under the Greenland ice. We have 3.5 million submarine volcanoes which cool from 1200 degrees Celsius to 2 degrees Celsius, the temperature of bottom water. Why has that been absolutely and totally ignored?
What? Do you want the cynical Joe Bastardi, the skeptical Joe Bastardi, or the, oh, let's all get along Joe Bastardi? I don't think they want to find out what the heck is really going on. I don't understand it anymore. I used to always, I always assumed the best. In fact, Dr. Jay Lair, the late Dr. Jay Lair, who I absolutely loved, he said, my problem is I'm too nice. That's what he always said, because I always assume the best about the other person. But your question brings up my question. Why the heck aren't we looking at that? At least look at it, and then you can dismiss it if you come up with conclusive proof. So the cynical me says they don't want to look at it. And now I'm the conspiracy guy from Letterman from years ago, right? So, but I don't think they want to look at it. Why not? What could it hurt? Except it'll blow the whole ESG idea apart if it's not CO2, right? By the way, I didn't know what ESG was. I thought they were a new rap band, and then...
Might as well.
Yeah, it's it destroys the narrative. Let's take some time to thank our speakers for being up here. Thank you for being here yourselves. Have 15 minutes for break. If you need something to drink or something, and the next science panel is in here. Begins at 10:45 sharp.
That was impossible.
That was pretty amazing. Hi.
Anything like that. When you look at data somewhere, like in our world of data or different news articles, a lot of the time what you will see is a data set that is labeled installed capacity. Often, this phrase is being used to mean the combined nameplate capacity of a field of turbines. So that's the amount of energy that can be generated by a field of turbines in ideal conditions. It's not the actual power that's being generated by the wind power plant. It almost never is. Nameplate represents the manufacturer's claim on the peak efficiency of the turbines. This is like when you buy a car. Let's use my car, for example, which is a 2016 Volkswagen GLI. The manual says that I can get 33 miles per gallon on the highway, but more often than not, there's other drivers on the road, so I have to accelerate and to brake, and that messes with your fuel consumption. Additionally, any little issue, maybe I didn't rotate my tires on schedule or get the oil changed right, any number of imperfections in maintenance can also impact the efficiency, and the same is true for wind turbines. Under ideal conditions, and this is usually something like a 30 mile per hour wind speed that is sustained, the optimal wind speed is actually different, though, depending on the type of turbine and the size of the turbine blades. So larger rotor blades can make use of a much lower wind speed, and that's the case for a lot of these offshore turbines, which are just huge. Installed capacity is usually calculated by taking that nameplate capacity, so the manufacturer's label, basically, of each turbine at an industrial wind facility, and then you add them all together. This being said, we all know that the wind doesn't blow at a constant speed all the time. So every wind project's actual power output is going to be different. Doing simple math here with numbers from our world in data on installed global wind energy capacity, we can estimate an average capacity factor of about 28.21% worldwide for wind power. The most often cited capacity factor for wind power is going to be about 40%, but as we can see, the actual number is probably quite a bit lower, only occasionally getting anywhere near 40%. So with all that out of the way, we can start talking numbers. So wind energy currently accounts for around 8.8% of net electricity generation in the United States, and worldwide it's about 5.3%. The top 3 countries with the most wind electricity generation are going to be China, the United
All right, hello and welcome to this special edition of Stopping Socialism TV, where we're going to be talking about Bernie Sanders and his potential run for president in 2024. We're going to get to that, but before I do, I just want to put that call out there that I do at the beginning of all these videos to all of our listeners and watchers here to help us out by just doing a couple of things. Won't cost you a penny, only cost you a couple of seconds, and that's hit that like button, share this content, subscribe if you haven't already, even leaving a comment underneath this video. All of these things help break through the big tech algorithm that prevents content like this from being shown to more people. So joining me today, I'm Donald Kendall, as always. I've got Chris Talgo, who's the editorial director here at the Heartland Institute, and also the author of this piece that we're going to be talking about, which is featured on stoppingsocialism.com, titled, Yep, Bernie Sanders is considering a 2024 presidential run. So, Chris, I thought probably like most people that when Bernie Sanders' campaign collapsed in the last two different primaries, that was going to be the last that we saw of him throwing his hat into the presidential ring. You're telling me that that's not the case and that he might be considering 2024. Explain yourself.
Telling you that you thought wrong, because if you thought that Bernie was going to go out after losing to the Democratic primary twice, nope, he's going to try a third time. So yeah, obviously in 2016, 2020, Bernie, lost the Democratic primary to Hillary Clinton and then Joe Biden. Although one can make a very good argument that both of those times Bernie, had a good lead and some things happened, and the powers that be decided we don't want Bernie, we want Hillary, we want good old Joe. So in some ways,
coin flips went against him in 2016. Yeah, so it says you've got quoted here a Bernie Sanders advisor, Faiz Shakur. I don't know how to pronounce that name, but it looks like he was on a CBS News interview, where he was saying, quote, "I assume that he would give it a hard look. I don't want to make the judgment for him, obviously. It would be his choice to make, but I assume that he would want to reevaluate it." So then he says here in this interview that personally, I take Joe Biden at his word, and our orbit takes him at his word that he's taking it seriously, and presume that he is leaning towards yes. They're talking about Joe Biden running for a second term. And he basically makes the case that if this wasn't the case, and that Biden wasn't going to throw his hat in, for a second term, that Bernie Sanders would be right there seeking that nomination. So I guess my question to you, Chris, my second question maybe, is Biden going to run a second term, or is he going to leave the door open for a good old Mr. Bernie Sanders here?
Oh, that's a very good question. And although Biden has hinted that he is going to run again in 2024, a lot of big-name Democrats do not want him to run in 2024. And just this morning, a pretty far-left radical group came out with an ad saying, "We do not want Biden to run again in 2024." So I would say right now, Biden probably wants to run again, but there's still a long way till 2024, and a lot could happen between now and then. So I wouldn't say it's a guarantee, but I would also say that, it's probably likely that he will.
Yeah, I mean, I know that some of these things have kind of turned around, especially right before the midterms, but it seemed like Biden had a lot of headwinds going against him, whether that's the high inflation that's still lingering around, high gas prices, which again have gone down, but still, twice as expensive as it was just a few years ago. A whole host of different controversies that surrounded Joe Biden that would seem to make him not a ideal candidate to run in 2024. But like I said, some of that stuff has reversed course, and he has been trying to promote his track record in the last couple of months as proof that he's being a good president. But do you think that there's a possibility that he will be primaried, even if he does decide to run, that he'll be primaried by somebody like Bernie Sanders?
So this is the big question. And, Joe Biden would like to think that his fortunes have reversed in recent months, but in reality, they haven't. You know why? Because his favorability ratings are at their all-time low. And the exit polls from the 2020 midterms showed that the American people disagree and disfavor Joe Biden, but they just didn't favor the Republicans for a whole bunch of other reasons. So it's not as if, the American people are saying, you know what, actually Joe Biden's doing a pretty good job. No, they're saying Joe Biden's doing a terrible job, but the other guys, at least in terms of the midterms, we don't really want what they're selling us either. So I do think that it's I'd say it's very likely that Biden could be primaried, maybe Bernie Sanders, maybe AOC, maybe who knows, someone else that comes out of the woodwork. But remember that this also has happened before to a sitting Democratic president. As the article, talks about, 1980, Jimmy Carter, kind of the same situation Biden's in, domestic agenda not going very well, very high inflation, a lot of energy problems, foreign policy-wise not going very well, Iranian hostage situation, Cold War wasn't really going our way. We were still having, the fallout from Vietnam, and guess what? President Carter did get primaried. Obviously, he, well, I shouldn't say obviously, but yes, he did win that contest, but he went on to lose in a spectacular fashion in the general election. So I'd say either way, things aren't looking that great for Joe Biden right now in terms of 2024, although obviously things could change.
Yeah, I mean, obviously, we know that Joe Biden is trying to toss some things to his younger supporters in terms of student loan pauses and student loan forgiveness. But Joe Biden has not been one to have a strong showing when it comes to younger Democratic voters. They seem to be mostly behind, whether it's like the squad members or Bernie Sanders, the so-called Democratic socialists and all of that. So it wouldn't surprise me too much if there was a push from some of these, some of these constituencies to see an alternative to Joe Biden. But I think the DNC would probably put the kibosh on that pretty quickly. They have to make sure that their candidate, if it is going to be Joe Biden, remains strong and unchallenged. And because you brought up the Carter thing, and Carter running against, who was he running against in that primary?
Ted Kennedy.
And I assume that was before my time, but I assume it was a knockdown, drag out type of a fight throughout the primaries, which I would argue probably hurt him come that general election against Reagan. So I can't imagine that the DNC would allow for like a serious contender to Joe Biden.
Well, especially one like Bernie Sanders, who is a Democratic socialist who wants to implement his socialist agenda. And part of the reason why Bernie lost in 2016 and 2020 is because the overlords of the Democratic Party knew that it would be catastrophic for them. So they said, no, we do not want Bernie to become the candidate. Now, it's very interesting because the base wants Bernie. The base wanted Bernie in 2016. The base wanted Bernie in 2020. And it's very likely the base is going to want Bernie in 2024, especially, like you said, those young voters, the Bernie bros. So Bernie is super popular with them. He's super popular on college campuses. Joe Biden, not so much. But Joe Biden has the big donors and the big wigs of the Democratic Party in his bed. So you're going to have a clash of these two titanic, powers at large here. You're going to have the voters, especially the, young voters who came out in record numbers in 2022 midterms, and the people who actually run the Democratic Party, like you said, the DNC and all those kind of people. It looks like it could be a very big reckoning here.
Yeah, it'll be very interesting to see. Obviously, it's far too early to really cement any of these things in play. If energy and gas prices start going up again, we get another bout of inflation. I think nothing is off the table in terms of challenging that position of Joe Biden as the candidate for the DNC. So I guess we'll see.
And just one more thing, a lot more could happen on the foreign policy front. China could invade Taiwan. We could have just a whole host of things. The situation in Ukraine is still very much up in the air. Joe Biden has done a very poor job of, maintaining world peace.
Yeah, also, we've talked about on this channel before, Joe Biden's mental state is not the sharpest, so that could also be an X factor in all of this too. That could leave the door wide open for a Bernie Sanders type. So Bernie Sanders at the spry young age of 81 right now would be closer to 83 come the 2024 election, which if he were to win, that would put him at 87 at the end of his first term. And looking at Bernie Sanders, that's not a young 87. So
no, but in all fairness, I must say that I think that Bernie Sanders is much more mentally articulate than Joe Biden is.
Sure.
Even though Bernie's actually 1 year older than Joe.
Okay. All right. So yeah, I'm very curious for all those that are tuning into this episode of Stopping Socialism TV. Is Bernie Sanders, do you think that it's realistic that he will run in 2024? Do you want to see him run? Do you want another taste of that Bernie burn, or are you done with this Democratic Socialist? Let us know in the comments. Chris, you have anything last words to say before we sign off for this segment?
No, I just hope everybody has a great holiday season.
Yeah, absolutely. And if you want to read this article in length, you can go to stoppingsocialism.com. It'll be, I think, right there on the front page. Chris does a fine job of adding new articles pretty much every day, I believe. And then if you want to see us on social media, we share most of this content across whether it's Facebook or Twitter or Instagram. If you look hard enough, you will find us on Stopping Socialism. thank everyone for tuning in, and I will talk to you next time.
Huge news just emerged from the Biden administration, and it affects your retirement. In November, the White House issued a new regulation that will allow investment fiduciaries, that includes the folks who are managing your 401k and other retirement accounts, to offer investment options that focus on something called environmental, social justice, and governance metrics. Commonly called ESG, these social credit scores are being used by elites and big banks, Wall Street firms like BlackRock, big tech companies like Google and Meta, and thousands of other corporations worldwide to completely transform America, its society, and its economy. Now, the Biden rule change will not require that plan managers force you to invest in woke companies or ESG funds. It's not going to force it, but it will allow your plan managers and employer to effectively coerce you into accepting them if you don't know how to get out of it. And it allows employers to make ESG funds the default option for your retirement account, even if you don't necessarily realize that that's what's going on. So you could be supporting ESG causes and you don't even know it soon. The Biden administration knows that because many large corporations have already gone all in on ESG, they will happily push their workers to do the same thing. Previously, this was not allowed. Under the Trump administration, this was illegal. But now, thanks to Joe Biden, it is legal, and it could have a massive impact on America. Trillions of dollars could soon flood into ESG funds and ESG compliant companies. Thankfully, there is something that you could do to stop that from happening. And no, it is not going to cost you any money. I'm not trying to get any money from you at all, I promise. My name is Justin Haskins. I'm a New York Times bestselling writer, conservative columnist, and public speaker who is actively trying to warn Americans about the dangers of ESG and the Great Reset movement. My work has been featured by many of the nation's leading publications, including the Wall Street Journal, National Review, FoxNews.com, the New York Post, and a whole bunch of others. And I've appeared hundreds of times on radio and television shows like Tucker Carlson Tonight and Fox and Friends, and the Glenn Beck radio program, and a whole bunch of other shows as well. So I'm not telling you about these serious problems to make money. I'm not asking you for any money at all. I just want you to learn the truth about what's going on with ESG, social credit scores, and the Biden administration. So if you're interested in learning more, please click on the link that's going to pop up on your screen and watch my video with Donald Kendall over at the Heartland Institute, where I also work and run its Socialism Research Center. And if you like the content that you see, please subscribe to our channel, Justin and Donald Save America. We talk about ESG, the Great Reset, Davos, the Biden administration, a whole bunch of other really important topics that you're not going to get in the mainstream press. And if you're particularly interested just in this topic, it is an absolute must that you watch our video on ESG and how ESG is going to be impacting your 401k potentially in the near future. Thank you for your time, and we hope to see you soon over at our channel.
special edition of Stopping Socialism TV, where we're going to be talking about Bernie Sanders and his potential run for president in 2024. We're going to get to that, but before I do, I just want to put that call out there that I do at the beginning of all these videos to all of our listeners and watchers here to help us out by just doing a couple of things. Won't cost you a penny, only cost you a couple of seconds, and that's hit that like button, share this content, subscribe if you haven't already, even leaving a comment underneath this video. All of these things help break through the big tech algorithm that prevents content like this from being shown to more people. So joining me today, I'm Donald Kendall, as always. I've got Chris Talgo, who's the editorial director here at the Heartland Institute, and also the author of this piece that we're going to be talking about, which is featured on stoppingsocialism.com, titled, Yep, Bernie Sanders is considering a 2024 presidential run. So, Chris, I thought, probably like most people, that when Bernie Sanders' campaign collapsed in the last two different primaries, that was going to be the last that we saw of him throwing his hat into the presidential ring. You're telling me that that's not the case and that he might be considering 2024. Explain yourself.
Telling you that you thought wrong, because if you thought that Bernie was going to go out after losing to the Democratic primary twice, nope, he's going to try a third time. So yeah, obviously in 2016, 2020, Bernie, lost the Democratic primary to Hillary Clinton and then Joe Biden. Although one can make a very good argument that both of those times Bernie, had a good lead and some things happened, and the powers that be decided we don't want Bernie, we want Hillary, we want good old Joe. So.
Yeah,
in some ways,
coin flips went against him in 2016. Yeah, so it says you've got quoted here a Bernie Sanders advisor, Faiz Shakur. I don't know how to pronounce that name, but it looks like he was on a CBS News interview, where he was saying, quote, I assume that he would give it a hard look. I don't want to make the judgment for him, obviously. It would be his choice to make, but I assume that he would want to reevaluate it. So then he says here in this interview that personally, I take Joe Biden at his word, and our orbit takes him at his word that he's taking it seriously, and presume that he is leaning towards yes. They're talking about Joe Biden running for a second term. And he basically makes the case that if this wasn't the case, and that Biden wasn't going to throw his hat in, for a second term, that Bernie Sanders would be right there seeking that nomination. So I guess my question to you, Chris, my second question maybe, is Biden going to run a second term, or is he going to leave the door open for a good old Mr. Bernie Sanders here?
Oh, that's a very good question. And although Biden has hinted that he is going to run again in 2024, a lot of big-name Democrats do not want him to run in 2024. And just this morning, a pretty far-left radical group came out with an ad saying, we do not want Biden to run again in 2024. So I would say right now, Biden probably wants to run again, but there's still a long way till 2024, and a lot could happen between now and then. So I wouldn't say it's a guarantee, but I would also say that, it's probably likely that he will.
Yeah, I mean, I know that some of these things have kind of turned around, especially right before the midterms, but it seemed like Biden had a lot of headwinds going against him, whether that's high inflation that's still lingering around, high gas prices, which again have gone down, but still, twice as expensive as it was just a few years ago. A whole host of different controversies that surrounded Joe Biden that would seem to make him not a ideal candidate to run in 2024. But like I said, some of that stuff has reversed course, and he has been trying to promote his track record in the last couple of months as proof that he's being a good president. But do you think that there's a possibility that he will be primaried, even if he does decide to run, that he'll be primaried by somebody like Bernie Sanders?
So this is the big question. And, Joe Biden would like to think that his fortunes have reversed in recent months, but in reality, they haven't. You know why? Because his favorability ratings are at their all-time low. And the exit polls from the 2020 midterms showed that the American people disagree and disfavor Joe Biden. but they just didn't favor the Republicans for a whole bunch of other reasons. So it's not as if, the American people are saying, you know what, actually Joe Biden's doing a pretty good job. No, they're saying Joe Biden's doing a
Ladies and gentlemen, please cease conversation, take your seats, silence cell phones, whatever you need to do. Please take your seats or take the conversation to the hall. We need to get started. We're behind time. This is panel 2A. I'm pinch hitting for a moment. We'll see if it winds up longer. It's understanding what's really happening to climate. If that's not the panel you wanted to hear, if you wanted to hear about the ESG, then you're in the wrong room. But if you're here, I'm going to assume that this is what you want to hear. I don't have the introductory materials for this, but we have a great panel, perhaps the most accomplished panel of any of the of many accomplished panels. We've got some really stellar people here. I'm happy to introduce Dr. Judith Curry will be joining us live remote. Ross McKittrick, Dr. Ross McKittrick, he's on stage here, and Dr. Richard Lindzen, who I've long been an admirer of. And I'm not going to belabor it because I didn't prepare introductory materials. I'm going to let them go. I think we're going to let Dr. Lindzen go first. Oh, well, now, let me ask. I see Ross McKittrick's thing up. Should he go first? Okay, Dr. McKittrick will go first. My apologies.
And just as I begin, can I get someone at the back to close the doors? And then that'll keep the hallway noise down. Thank you. So I'm speaking about the social cost of carbon and some work that Kevin Diaratna and I have just published in a journal on this. Now, the backstory is we published a paper with the late Pat Michaels back in 2020 in a journal called Environmental Economics and Policy Studies. And what we did there was we took one of the models that was used by the EPA to calculate the social cost of carbon, and we updated it to reflect more recent evidence in the literature on some of the key parameters, and showed that it made quite a big difference in the estimate. And I'm going to explain what the social cost of carbon is, or at least what it's purported to be. There's a large literature here that's aimed at generating estimates of the social cost of carbon, and we made a contribution to it. And then more recently, someone published a critique of our work. And so the new publication that Kevin and I did that just came out is a response to that critique. All right, so social cost of carbon. Love it or hate it, this number plays a big role in a lot of regulatory decisions. It's basically why we can't have nice things anymore. The social cost of carbon calculations are very dependent about a handful of assumptions in the key models that are being used. Now, if the number comes out near zero, that implies that releasing a ton of CO2 emissions doesn't really have any negative economic consequences. And if that's the case, you can't justify costly abatement policies. So for a long time, the economics literature has been putting out a lot of results that says the social cost of carbon is pretty close to zero, may even be negative. And so on a cost-benefit basis, most of the climate policies that get discussed fail the test. As a result, governments around the world are conspicuously trying to find reasons to boost the social cost of carbon estimates. And so there's a few key things that they can do, like introducing tipping points into the model, or mortality functions, or agricultural damages, or anything. And there's a kind of a contest in the literature who can publish a tweak that generates large social cost of carbon numbers, because regulators will love it, and your work will get praised and highlighted. The work goes on in what are called integrated assessment models. So these are combined climate and economy models. They were first developed by William Nordhaus at Yale University, who eventually got a Nobel Prize in economics for this work. And the model runs an economy and a climate together over time and solves for the optimal social cost of carbon, optimal based on all the assumptions about the sensitivity of the climate to greenhouse gases, the damages from warming, and the costs of reducing greenhouse gas emissions. And it's especially that last part that matters. The cost of reducing greenhouse gas emissions is very high. And as a result, integrated assessment models have traditionally shown that most of our mitigation policies aren't worth doing. Nordhaus's work himself has shown that for the most part, you just have to live with it. That you can't really justify expensive emission abatement policies. And the way that's expressed in economic parlance is the optimal price of carbon is too low to justify aggressive emission cuts, certainly too low to justify net zero targets. Now, key parameters, first one is equilibrium climate sensitivity. And this is a parameter in the model that says how much warming would you get if the amount of CO2 doubles in the atmosphere. And obviously, if you have more warming, then that has bigger effects on the economy in the model. The discount rate is the parameter that says how much you should downweight costs and benefits that happen in the future compared to those that happen in the present. And then the CO2 sensitivity refers to how much agriculture productivity is boosted by having additional CO2 in the air. Now, the equilibrium climate sensitivity in these models, as used by the EPA, is based on something called the Rowe-Baker distribution. So the Rowe-Baker distribution, this was from a study published in 2007 that looked at the behavior of a whole bunch of climate models, and they drew that green line that you see there, a distribution of possible climate sensitivity estimates, and it ranges from a low of 1.5 degrees up to about 7.5 degrees at the upper end, and it has a median of 3 degrees. So when the EPA runs these integrated assessment models, they run it thousands and thousands of times and draw samples from the Rowe-Baker distribution, and then they get a distribution of social cost of carbon estimates. And they did that with 3 major integrated assessment models that go by the names of DICE, FUND, and PAGE. Now, as far as the discount rate, the Office of Management and Budget recommends for public projects a 7% discount rate. In the climate literature, a lot of economists say, well, if we're talking about such long time horizons, we should use a lower discount rate. So typically in climate economic studies, people vary the rate from 2.5% to 7% just to see what the effect is. And then the CO2 fertilization, there's one model, the FUND model, that includes benefits to agriculture from all the extra CO2 in the air. The 2 others just ignore the effect altogether. So they don't have a CO2 fertilization effect at all. Now, what we did, Pat and Kevin and I, we took the FUND model and we made a couple of changes to it. So first of all, we took out the Rowe-Baker distribution and we used a new empirically based climate sensitivity distribution due to Nick Lewis and Judy Curry. And that distribution had a mean or a median sensitivity of 1.6 degrees and a range of 1.2 to 2.2. And this was based on, not on running climate models over and over, but based on observations over the 19th and 20th century applied in an estimation model. And then there's another estimate John Christie and Dick McNider did using lower troposphere data, which came up with a median estimate of 1.4 degrees and a range of 1.1 to 1.8. Obviously much lower than the Rowe-Baker distribution, and consequently they generate lower social cost of carbons. As far as the CO2 fertilization effect, the FUND model was set up based on information available in the early 1990s. Since then, there's been a ton of work on global greening and also the plant benefits, agricultural benefits of CO2. And so we used a meta-analysis published by Challenor et al., which showed that the CO2 fertilization effects are much larger than what had been anticipated 20 years earlier. So we tested for 15 and 30% increases in the fund model agricultural productivity parameters. And then we used a variety of discount rates. So the results of that paper, if we stick with the Rowe-Baker ECS estimate, but we increase the CO2 fertilization by 15%, that didn't have a big effect. The social cost of carbon falls by about 4%. But if we go up to a 30% increase, the social cost of carbon falls by about 25%. The bigger effect, though, is updating the ECS distribution using either Lewis and Curry or Christie-McNider. That causes the social cost of carbon estimates basically to fall to zero out through 2050. Even without increasing the CO2 fertilization effect, the social cost of carbon falls from the mid-30s down to under $5 using a 2.5% discount rate, and falls to minus 77 cents using a 5% discount rate. So the results look basically like that. The upper line is the result the EPA calculated using the Rowe-Baker distribution. The three lower lines are what we got using either no increase in CO2 fertilization or 15 or 30% increase. And those are the estimated social cost of carbon rates from 2020 out to 2050. Any one of those three lines would mean you can't justify any climate policy on cost-benefit grounds. Okay, so then a comment was published last year by Philip Meyer. We don't really know anything about him except he's a US government employee somewhere. He pointed out that the Lewis and Curry 2018 paper has been superseded by a new study by Nick Lewis, which was published last year, which has a median ECS of 2.2 degrees. He also argued that the Christie and McNider estimate isn't really relevant because people live on the surface, not in the troposphere. He argued that Challenor meta-analysis has been superseded by an analysis by Moore et al., which has a very large data set, and they found much smaller CO2 benefits and net losses from warming. And then going over the discount rate issue, he said the DICE model has close to a 5% discount rate, so that would be an appropriate one to use. He didn't recalculate the social cost of carbon estimates, so we go through all his comments and then do it for him. And so our responses to that, first is, yes, the new paper by Lewis is a good analysis. What Lewis did was, in the most recent IPCC report, they've stopped using climate models to generate their distribution of ECS estimates. Instead, they latched onto a study by Sherwood et al., which combined paleoclimate and modern instrumental data and came up with an empirical estimate. And what Lewis did was he showed that, okay, that's a valid method, but they were using older versions of the data sets. And if you update the data sets, and even the IPCC has updated the data sets, the median distribution falls to 2.2, which is well below the IPCC's estimate of 3.1. But also, if you confine it just to the instrumental data set, their method gives you 1.8C, which is pretty close to what he and Judy Curry had estimated before. On the second point, we point out that the troposphere data is actually ideal for the purpose. Yes, people live in cities on the surface, but that contaminates the surface temperature data, as the last panel discussed. So the tropospheric data, if you want to isolate the effect of CO2 on warming, that would actually be an ideal data set to use. The Moore et al. Study just reused the Challenor data set. It wasn't a new data set at all. What they did was they changed the estimation method, but they didn't provide any details about their modeling assumptions, but you can tell that they use different functions that just suppress the CO2 effects and the benefits of adaptation. And so we don't find that a credible advance on the earlier work. And then finally, okay, 5%, we'll go with that. So the new result, if we use, first of all, if we used a 2.5% discount rate and the new 2.2 degree ECS, and we don't change the agricultural fertilization effect, then the new result's about midway between what we published a couple of years ago and the old Rowe-Baker analysis. So the Rowe-Baker result would be the top red arrow. The result we published a couple of years ago is the bottom red arrow. The new result, based on the Lewis distribution, would be the red arrow in the middle. But there's still a 15% chance the social cost of carbon would be less than zero as of 2050. If we use the 5% discount rate, the numbers there are probably too small for you to read, but under any assumption, using the 5% discount rate, but whatever CO2 fertilization effect we put in, using the Lewis 22 ECS estimate, the social cost of carbon is $3.39 as of 2050, and that's the highest it gets. So putting all these things together, if we look at the social cost of carbon at 2050 using a 5% discount rate, under the Rowe-Baker distribution, it's over $5, but using the new Lewis 22 distribution, it's $3.39, 33% probability that it's below zero, meaning CO2 is a net benefit. Whichever one of these we choose, and the Christie-McNider estimate there is minus 72 cents. Either way, and again, these are the models the EPA themselves used, you can't justify any climate policies on cost-benefit grounds using these kinds of numbers. I'm almost done, actually. So the conclusions that we reach, in our 2020 paper, we showed that updated empirical evidence yields social cost of carbon near zero, at least through 2050. We don't agree with all of Meyer's recommendations, but if we take them at face value, the result is that the social cost of carbon remains very close to zero or below zero for many decades, and the resulting social cost of carbon number is well below any level that would justify current mitigation policies. Now, none of this is to say that we agree with those models or with the parameter choices or things like that. The point here is to say, okay, this is how you guys constructed the case for your regulations, but you haven't used very good data in your models. So if we improve the data in your models, your own models say that you can't justify the policies. Working in a field like social cost of carbon calculations, it's always a moving target. So more recently, what's happened is the EPA seems to be gravitating towards a study that was put out by Resources for the Future, which now gets rid of all the integrated assessment models and has brought in a couple of brand new ones that no one's seen before. And they have much, much higher social cost of carbon estimates. So it's now going to be back to the drawing board to take those apart and figure out why it is that even though they've also conceded that the emission projections are way too high, so they've cut their emission projections quite a bit, but they're still getting, well, now their social cost of carbon estimates is about $170 a ton. So there's some magic sauce in there somewhere, and like I say, they're not even using the models that they used a couple of years ago, the 3 integrated assessment models, including the one that got a Nobel Prize. Now those are out the window, and they have brand new ones that we haven't seen before. So it's a moving target, like I say, but those are the last few findings that we've got into the literature. Thank you.
We've got Dr. Curry's online talk already queued up, so we're going to go with her next, and then Dr. Lindzen will be the closing act, the old headliner, as they used to say with concerts when I would manage concerts.
Even people that don't know much about climate science have heard that 97% of climate scientists agree. But exactly what do they agree on? Not nearly as much as is portrayed in the media. Everyone agrees that surface temperatures have increased since 1880. Humans are adding carbon dioxide to the atmosphere, and carbon dioxide and other greenhouse gases have a warming effect on the planet. However, there is much disagreement on the most consequential issues. How much of the recent warming has been caused by humans? How much the planet will warm in the 21st century? whether warming is dangerous, and how we should respond to the warming to improve human well-being. The first 2 points are in the realm of science, requiring logical arguments, model simulations, and expert judgment to assess whether and how much. The issue of dangerous is an issue of societal values about which science has little to say. Whether reducing CO2 emissions will improve human well-being is an issue of economics and technology. This is also contingent on the relative importance of natural climate variability versus human-caused global warming for the 21st century. Nevertheless, we are endlessly fed the trope that 97% of climate scientists agree that warming is dangerous and that science demands urgent reductions in CO2 emissions. So why do scientists disagree? The most fundamental source of disagreement regarding the theory of human-caused climate change is natural climate variability. Why do climate scientists disagree on the relative importance of natural versus human-caused climate change? Well, the historical data is sparse and inadequate, particularly in the oceans. There's disagreement about the value of different classes of evidence, notably the value of global climate model simulations and paleoclimate reconstructions. There's also disagreement about the appropriate logical framework for linking and assessing the evidence. And finally, there's little acknowledgement that some climate processes are poorly understood or even unknown. Science works just fine when there's more than one hypothesis to explain something. In fact, disagreement spurs scientific progress through creative tension and efforts to resolve the disagreement. In the 1990s, the IPCC made a fateful decision to formulate their reports around consensus. The IPCC arguably adopted a speaking consensus to power approach that sees uncertainty and dissent as problematic and attempts to mediate these into a consensus. The speaking consensus to power strategy acknowledges that available knowledge is inconclusive and uses consensus as a proxy for truth. The consensus to power strategy reflects a specific vision of how politics deals with scientific uncertainties. The IPCC's manufacture of consensus has done incalculable harm to climate science and the policymaking that is informed by climate science. An explicit consensus-building process has enforced overconfidence and belief polarization. Consensus beliefs are serving as agents in their own confirmation. Dismissal of skepticism has been detrimental to scientific progress. Over-reliance on expert judgment has motivated shortcuts in reasoning and hidden biases. And finally, narrow framing of the climate change problem has provided a basis for neglecting research in certain areas. So how did we come to the point when we're alleged to have a future crisis on our hands, but the primary solution of rapid global emissions reductions is deemed to be impossible? The source of this conundrum is that we have mischaracterized climate change as a tame problem with a simple solution. The climate change problem is framed as being caused by excessive carbon dioxide in the atmosphere, which can be solved by eliminating fossil fuel emissions. Both the problem and solution are included in a single frame. This framing dominates the UN negotiations on climate change. The framing on the right addresses climate change as a complex, wicked problem. This framing shows two separate frames, one associated with the causes of climate change and the other associated with solutions that can help reduce vulnerability to climate change. The larger frame on the right also includes natural causes for climate change, such as the sun, volcanoes, and slow circulations in the ocean. This framing is provisional, acknowledging that our understanding is incomplete and that there may be unknown processes influencing climate change. The frame on the left is about controlling the climate, whereas the frame on the right is about understanding the climate. Further, the framing on the right acknowledges the futility of control. Solutions on the right focus on managing the basic human necessities of energy, water, and food. Economic development supports these necessities while reducing our vulnerability to weather and climate extremes. My own understanding of climate change and human well-being is squarely in the framing on the right. The climate crisis isn't what it used to be. Circa 2013, with publication of the IPCC Fifth Assessment Report, the extreme emissions scenario, RCP 8.5, was regarded as a business as usual emissions scenario, with expected warming of 4 to 5 degrees centigrade by 2100. Now there is growing acceptance that RCP 8.5 is implausible, and RCP 4.5 is arguably the current business as usual emissions scenario. And this is according to recent reports issued by the COP 26 and 27. Only a few years ago, an emissions trajectory that followed RCP 4.5 with 2 to 3 degrees centigrade warming was regarded as climate policy success. As limiting warming to 2 degrees seems to be in reach, the goalposts were moved in 2018 to reduce the warming target to 1.5 degrees centigrade. Climate catastrophe rhetoric now seems linked to extreme weather events. For nearly all of these events, it's difficult to identify any role for human-caused climate change in increasing either their intensity or frequency. The mainstream media is currently awash with articles from prominent journalists on how the global warming threat is less than we thought. The rationale for continuing to increase the alarm is that the impacts are worse than we thought, specifically with regards to extreme weather. Attributing extreme weather and climate events to global warming is now the primary motivation for the rapid transition away from fossil fuels. This rationale commits the logical fallacy of conflation. There are two separate risk categories for climate change. The first is impacts of the slow creep of global warming on sea level rise, contribution to regional water shortages, and hypothesized tipping points. The second is extreme weather events and interannual climate variability, which has little, if anything, to do with global warming. The proposed management strategy for both risk categories is to eliminate CO2 emissions. This strategy may have some incremental benefits in the 22nd century, but will not help with the emergency risks associated with extreme weather events. The appropriate way to deal with the emergency risk is fundamentally regional through economic development and vulnerability reduction. The urgency of addressing emergency risk is being used to motivate the urgency of reducing the incremental risk from emissions. Ironically, attempts to reduce emissions are exacerbating energy poverty and unreliability, which is increasing the emergency risks. One would logically think that if warming is less than we thought, but impacts are worse, that the priorities would shift from CO2 mitigation towards development and adaptation. However, that hasn't been the case. How did we come to the point where the world's leaders and much of the global population think that we urgently need to reduce fossil fuel emissions in order to prevent bad weather? Not only have we misperceived the climate risk, but politicians and the media have played on our psychological fears of certain type of risks to amp up the alarm. Psychologist Paul Slovic describes a suite of psychological characteristics that make risks feel more or less frightening relative to the actual facts. In each of the risk pairs on the left half of the slide, the second risk factor in bold is perceived to make the risk worse than it actually is. For example, risks that are common, self-controlled, and voluntary, such as driving, generate the least public apprehension. On the other hand, risks that are rare and imposed and lack potential upside, like terrorism, invoke the most dread. Activist communicators emphasize the man-made aspects of climate change, the unfair burden of risks on undeveloped countries and poor people, and the more immediate risk of severe weather events. The recent occurrence of infrequent events, such as hurricane or flood, produces elevated perceptions of the risk of low probability events. This then translates into perceptions of overall climate change risk. The cultural theory of risk proposes that our views on risk are filtered through cultural worldviews about how society should operate. Our perceptions of climate risk have been cleverly manipulated by propagandists. Even if the initial harm from climate change is small, the social risk is being greatly amplified by the collective responses and irrational behaviors of individuals. The response to climate risk, driven by alarmism and extinction rhetoric, has arguably crossed the threshold to actually increasing the social risk associated with climate change, including increasing risk from energy poverty and unreliability. Leading risk scientists and philosophers who don't have a particular dog in the climate fight have expressed their concern about how all this has evolved and where it is headed. Norwegian risk scientist Terje Aven has this to say: "The current thinking and approaches have been shown to lack scientific rigor, the consequence being that climate change risk and uncertainties are poorly presented. The climate change field needs to strengthen its risk science basis to improve the current situation." Philosopher Thomas Wells has this to say: "The global climate change debate has gone badly wrong. Many mainstream environmentalists are arguing for the wrong actions and for the wrong reasons, and so long as they continue to do so, they put all our futures in jeopardy." One of the reasons that the global climate change has gone badly wrong is that we have created problems at the interface between climate science and policymaking. Encroachment of politics into socially relevant science is unavoidable. Problems arise from many sources, and scientists, policymakers, and the media are all culpable. Policymakers misuse science by using science as a vehicle to avoid hot potato policy issues, by expecting black and white answers to complex problems, demanding scientific arguments for desired policies, and funding a narrow range of projects that supports preferred policies. Scientists misuse policy-relevant science by playing power politics with their expertise, conflating evidence with expert judgment, ignoring data and research paths that undermine their political preferences, entangling disputed facts with values, and intimidating scientists whose research interferes with their political agendas. Climate science is far from the only area of science that has been politicized. Others include COVID-19, gender studies, and genetically modified food. Cancel culture is alive and well in the sciences, where scientists that disagree with an interpretation that supports desired policy objectives are ostracized, with some even losing their jobs. The wickedness of the climate problem is related to the duality of science and politics in the face of an exceedingly complex problem. There are two common but inappropriate ways of mixing science and politics. The first is scientizing policy, which deals with intractable political conflict by transforming the political issues into scientific ones. The problem with this is that science is not designed to answer questions about how the world ought to be, which is the domain of politics. The second is politicization of science, whereby scientific research is influenced or manipulated in support of a political agenda. We have seen both of these inappropriate ways of mixing science and politics in dealing with climate change and also the pandemic. There's a third way, which is known as wicked science. Wicked science is tailored to the dual scientific and political natures of wicked societal problems. Wicked science uses approaches from complexity science and systems thinking in a context that engages with decision makers and other stakeholders. Wicked science requires a transdisciplinary approach that treats uncertainty as of paramount importance. Effective use of wicked science requires that policymakers acknowledge that control is limited and that the future is unknown. Effective politics provides room for dissent and for disagreement about policy options and includes a broad range of stakeholders. I have a new book that is in press entitled Climate Uncertainty and Risk. The subtitle for the book is Rethinking the Climate Change Problem, the Risks We Are Facing, and How We Can Respond. This book encompasses my own philosophy for navigating the wicked problem of climate change. As such, this book provides a single slice through the wicked terrain. By acknowledging uncertainties in the context of better risk management and decision-making frameworks, in combination with techno-optimism, there's a broad path forward for humanity to thrive in the 21st century. In many ways, this ICCC meeting is wicked science in action, with scientists, policymakers, journalists, business leaders, think tanks, and advocacy groups all in the same room. A broad range of perspectives is being presented and discussed at this meeting. Our challenge is to effectively harness all this in context of complexity science and systems thinking. The next time someone calls you a denier, you can respond with this: give me a break. I'm a wicked scientist. Thank you.
Dr. Richard Lindzen's next.
Okay. Well, let's see if I can see my slides. Yeah. Okay. The title is a little bit excessive, but it describes what I'm going to talk about, which is what I think climate is really doing, why I fear it doesn't matter with respect to policy, and why I think that matters might still turn around. Does this work? Yeah. Okay, here is a graph. Many of you may not have seen it. It's a simple graph John Christie and I put together. The vertical axis is temperature, degrees centigrade, and the horizontal axis is just various kinds of climate change that people know how to handle. Of course, these vary from place to place, and we've taken it from various cities in the US, all over the US, Seattle, Boston, so on. And at the far left, what you have, I don't know, no, I can't use a pointer. At any rate, is the warming we've seen over the past 120 years. That's barely budging off the bottom. And then we go to things like, from 8 a.m. to 10 a.m., and from sunrise to afternoon, and so on. And of course, it's increasing to very large amounts. And we deal with all of those. So a question arises, and the question is the following. How is it that the small seeming change in global mean temperature anomaly is taken to imply major climate change? And people don't deal with it. I notice even at this meeting, we bloviate about 2 degrees or 1.1 degrees and so on, and never deal with the fact we're dealing with something tiny that shouldn't be a problem. Well, let's consider. The answer, especially with Sherwood's use of paleoclimate, is something called polar amplification. The idea here is that the mean temperature change, for instance, during the Ice Age or during the Eocene, was around 5 degrees. And if 5 degrees in the change in the mean can be such remarkable change as a major ice age or the so-called climate optimum of the Eocene, then we better worry about small changes in sensitivity if they start approaching that. But where did this notion of polar amplification come from? And again, nobody is dealing with that here, but it turns out to be a crucial idea. It comes from paleo data, and that's what I've just mentioned. In paleo data, the change in the tropics to pole temperature difference, I'm referring to it here by little delta T2, is listed here. So you have these changes in the tropics to pole, 20 degrees in the Eocene, 40 degrees today, 60 degrees roughly during the glacial maximum. And they were accompanied by small changes in tropical temperature. Now that has its own interesting history, and I won't dwell on it too much. The original studies of these phenomena, for instance, for the glacial maximum, actually had tropical temperatures increasing. And the original study by Shackleton in Burmsa for the Eocene had tropical temperatures decreasing. And that didn't look at all like what the climate alarmists were saying. So there's huge efforts to change it. And currently, the feeling for the Eocene by someone called Dan Schrager at Harvard is that it's the same as today. Nothing occurred. And for the glacial maximum, they've managed to squeeze out the possibility that it was also a degree cooler in the tropics. Okay, you talk about fudging data, it gets easier as you go back further, but all I'm saying is it's always small compared to this. So the idea was, this could mean that small changes cause it, but the question is, was this really polar amplification of the small and uncertain tropical temperature change? And let's look at it. This is a kind of schematic of the temperature of the Earth. The horizontal axis is sine of latitude, so it gives an area averaging. The boundary between the tropics and the extratropics at x1 corresponds roughly to x1 equals a half, which is 30 degrees latitude. And you can go to the reference there if you want to derive it, it's trivial. But the average temperature here will be T1 minus this delta T2 fraction 1 minus x1 over 2. So that'll be roughly 1/4. Okay, so there you have a simple formula. And if you apply it to major climate change, what you find is, for the delta T2 component, you get about plus or minus 5 degrees, because it's 20 degrees change in delta T2, and you get almost nothing for delta T1. What that means is, obviously, that delta T bar is dominated by the second term, the change in tropics to pole temperature difference. Fair enough. But there's another question. Do we see anything like this in the current warming episode? And the answer is no. Here is the change in the tropics to pole temperature difference over the period 1880 to 2020. As you know, it gets smaller, it gets larger, it wobbles all over the place. It has almost no bearing to the mean. Moreover, the numbers, and I can barely see the index, but if you divide them by 4, they're pretty tiny. And you can see that now by comparing the mean temperature and the tropics, the global temperature. Orange is the global. And basically, the global tracks the tropics and is generally smaller and irregular. So we're dealing with 2 different climate changes. We're calculating our climate sensitivity based on the present, which seems to have nothing to do with major climate change. This is profoundly different. What's going on? Well, what's going on, in fact, is physics. The tropics and the extratropics represent profoundly different dynamical regimes. People here in Florida, I think, probably realize the tropics are very different from the extratropics. The prevailing winds are easterly in the tropics. In the extratropics, they're westerly. The major perturbations in the extratropics are the highs and lows that we associate with weather. We don't see the same type of thing in the tropics. They're smaller. There is a large Hadley circulation in the tropics. It ends at the subtropical jet, which forms the boundary to the extratropics. At any rate, so what's determining this? Why are the 2 profound regimes there? And it is because of the rotation of the Earth. I hope most of you are familiar with the term Coriolis force. Coriolis force effectively depends on the vertical component, the component perpendicular to the surface of the rotation vector of the Earth. So that's on the right there. And in the extratropics, the component perpendicular is significant, and in the tropics, it's almost parallel to the surface and does not inhibit cross isobar flow. What does that mean? Well, we'll see that in the next slide. The pictures again. The cross isobar flow in the tropics homogenizes horizontal temperature differences. And that, you'll see, is a characteristic of the tropics. The temperature differences with latitude are minimal. It tends to be pretty homogeneous. On the other hand, where you have a Coriolis force in the extratropics, it inhibits wiping out the gradients, and we have the gradients. On the other hand, it has limits. It is due to an instability, and if you go beyond a certain point, the instability stops. And what did I just do here? I pushed the wrong button. Yeah. Okay. At any rate, so you have the cross isobar flow homogenizing the tropics. In the extratropics, you have what is called baroclinic instability, the highs and lows. And their limit, it turns out, it's a really hard calculation. It was done by colleagues Malta and Ferrari at MIT. What it determines is the slope of one of these bars. What these bars are isentropic surfaces. For those of you who know meteorology, those are surfaces in potential temperature. And baroclinic instability says that the isentrope along which transport occurs, that leaves the surface at the boundary of the tropics, that isentrope has a slope, and that slope determines the polar tropopause. Okay, that's technical, but it determines the temperature difference between the tropics and the pole at the polar tropopause level, about 6 kilometers. And it sets it to about 20 degrees. That's an interesting number. That is the temperature difference during the Eocene, when we had no ice and so on. You'll notice some of these bars originate not in the tropics, but at the surface. And they have an important role as well. The ones originating at the surface allow the influence of extratropical surface conditions, including the role of ice, which produces what's called the Arctic inversion, and the influence of ocean transport. But the crucial thing is the processes that determine the temperature difference are extratropical. On the other hand, the temperatures that determine the tropics do depend on the greenhouse. And the fluxes in and out. But turning back to this, it's telling you you do not have polar amplification. On the contrary, whatever is happening in the tropics is just an additive constant to the temperature everywhere. And so if you have 1 degree, 1.5 degrees, it doesn't give you a big thing in the Arctic, it gives you 1.5 degrees. And we've been sort of screwing around and ignoring the general circulation. Without polar amplification, small warming remains small warming. And for major climate change, like the Eocene or the Ice Ages, greenhouse-based climate sensitivity is largely irrelevant. Okay, in point of fact, although this is a major problem, it's completely ignored. But, you know, part of the reason it's ignored is virtually every aspect of warming alarm narrative is faulty. Despite this, I think it is fair to say we are losing the battle in the policy arena. I differ with Greg on this, and I'd like to ask, why are we losing this battle? And the answers are pretty obvious. The alarmists control the funding, which allows them to entrain many scientists and scientific organizations, including the American Medical Association. I mean, this is crazy. For anything we show, there will always be some so-called scientist who will claim the opposite. They've been paid to. They take advantage of the insecurity of the public to denigrate skeptic claims because they point out if the skeptics are wrong, then the public is at severe risk. They personally have more at stake financially. And they've learned from Goebbels that a big enough lie, repeated endlessly, becomes truth. And they are more sophisticated in preserving the narrative. And let me explain that. It took me a long time to realize that. They realize the utility of overt errors. So for instance, you point to things that have no relation perhaps to climate, but have the capacity to frighten people. Wildfires, extremes, obesity, autism, God knows, you'll have all of them associated with climate. And what is the implication? I think the people saying this know it's nuts. But the implication somehow is left that if they weren't misrepresented, they imply decarbonization. And so you could skip over all the logical steps that would be needed to do that and establish that if you see people getting fatter, it means you have to get rid of carbon dioxide. Keep the skeptics busy pointing to errors in things like climate sensitivity, while not questioning the narrative that the greenhouse effect determined major climate change. I'm as guilty as anyone of this. You know, you looked at the feedbacks and you said, these don't make sense, we don't know enough, and so on. And you forget that climate sensitivity calculated this way may not be the relevant thing to do. I have to give credit to Tony Heller, who quickly realized this because of a very simple thing. I mean, he was not into dynamics, but the climate of the Earth has dozens of climate regimes. How did one number correspond to sensitivity of this system to anything? The appeal to the insecurity of non-scientists is very important. A vast majority of the population cannot deal with graphs, numbers, and so on. We know this, and know it at the university from our humanities colleagues. So you appeal to their insecurity. They feel insecure about this by providing simple to understand narratives, even if they're wrong. So for example, when an Al Gore tells you CO2 is a blanket, that's a lot simpler than what I've been telling you. And its simplicity is a source of comfort to the scientifically illiterate. Okay, so where does this leave us? No. Humor is always a potent weapon, and we use that often. And I won't dwell on it much, but at MIT we have somebody who's anonymous called the Babbling Beaver. The beaver is the mascot of MIT. And he makes fun of what we're doing there. MIT is gathering our librarians to train climate catastrophists to control Wikipedia's narratives, and describes this in detail as a crazy thing MIT is doing. Some approaches defy parody. We make fun of the Medical Association, but this one I don't think you've seen. Came from a friend who is a professor of musicology, and it's a forthcoming meeting in Essen, Germany on music and climate change, artistic action in times of crisis. I could read it to you, but I don't think it would help you or me understand what the hell they're talking about. Inconsistency obviously doesn't matter. The Boston Globe, I think 2 days ago, had the following. It was describing the fact that we had a cold spell. It was really very cold, and 3 or 4 hospitals, I think 3 hospitals, had broken pipes, and they couldn't admit ambulances with emergencies. And so they were saying, here's an example of how climate is preventing health care. And then what do they conclude? Well, unfortunately, I have to go back. Can you go back on this? Yes. You can't see it. Somehow the slide screwed it up. Their conclusion is climate change is stealing New England's winters when they've just been talking about frozen pipes. I don't know. In any event, ordinary people do remain skeptical. For obvious reasons, the things that they're presented with are kind of nuts. The educated elite seem most vulnerable, and people have mentioned Orwell, and he did famously say, there are some things so stupid that only intellectuals could believe it. And there are reasons for that. I mean, what is the good student except the person who can rationalize whatever the professor says? So, but in any event, I think people in general of goodwill do want to believe that their government is not out to get them, which may be a false wish. There follows my take on the issue from 31 years ago, and I'll read that to you. Such weak predictions feed and contribute to what I have already described as a societal instability that can cascade the most questionable suggestions of danger into major political responses with massive economic and social consequences. I've already discussed some of the reasons for this instability: the existence of large cadres of professional planners looking for work, the existence of advocacy groups looking for profitable causes, the existence of agendas in search of saleable rationales, and the ability of many industries to profit from regulation, coupled with an effective neutralization of opposition. It goes almost without saying that the dangers and costs of those economic and social consequences may be far greater than the original environmental danger. That becomes especially true when the benefits of additional knowledge are rejected and when it is forgotten that the improved technology and increased societal wealth are what allows society to deal with environmental threats most effectively. The control of societal instability may very well be the real challenge facing us. This was 1992. Well, we're now in 2023. We failed to control the societal instability. However, the pain, the evil, and evident uselessness associated with the proposed policies seems to be turning the tide. After all, normal people will, one hopes, want a second opinion before being forced to suffer, especially if the suffering serves no environmental purpose, regardless of what one thinks about climate. Thank you.
Before I open it for questions, I'm going to share an anecdote because I was listening to Dr. Linzen, and you have to know me and my father's relationship. He's very proud of me. First in college, got a PhD, and he knows, politically where I stand, and he knows politically where he stands, and so he calls me up and gives me a hard time every so often. And he called me up one day, and he had heard on the news about a new study that shows that climate change is increasing impotency among men. He says, "Now do you believe? Now do you believe?" He just cackled. He thought that was so funny, like that was gonna all of a sudden change my mind. So, note on questions. We got plenty of time for questions. I wanna get through as many as possible. So, I will recognize you. A monitor will come over with the speaker. I ask that you stand, identify yourself, ask the question to a particular speaker, but there's no follow-ups, there's no statements. We want to get through as many as possible. Nathan, could you please go him and then...
I'm Manali Darakshani from New York. This is a question for Dr. Linzen. I agree with you that the educated elite are the most prone to alarmist propaganda. And it seems to me that the most compelling argument to the educated elite is the alleged 97% consensus among climate scientists and scientists more generally. And it seems to me if we want to make headway with the educated elite, we have to do our absolute best to convince them that they've been lied to about this particular consensus by reputable organizations, allegedly like NASA and the United Nations and so on and so forth. Do you agree with that?
Not entirely. At a more cynical level, I think nothing will help the educated elite. But there's also another problem, and that is who speaks for NASA, who speaks for these organizations. I mean, I have personal familiarity with some of the modelers. I know that they know that their models are in fact producing net benefit. They can't stress that to the funders. The work I did on the iris effect was done with NASA. In all these organizations, the names are used to intimidate the people who are not familiar with the details. Even the IPCC, Steve Koonin has this book, which I think is very fine. It has nothing to do with making a scientific case for no warming. Rather, it's saying, what does the official documentation say? So you go to the scientific section of the IPCC. Does it speak of an existential threat? No. It speaks of something very modest. You go to all these documents, and it's the things you've heard early in the meeting, these trends are not occurring, and so on. So the question is, this 97%, yeah, it's a number people like to quote, but he's pointing out the documents that they're basing this on don't say anything of that sort. So when you start attacking NASA, you start attacking NOAA, and so on, there will be an official there that may justify your attack, but very often their documents don't.
Bill Lindquist from conservative Marin County, California. Question for Ross. Ross, do you know, are there any plans to hold the EPA along with yourself and several knowledgeable real scientists before one of the House committees in Washington to question the EPA and have them defend the information that they've come up with that are determining a lot of these false policies by the agencies?
I'm not personally aware of any scheduled hearings. It would likely be a possibility in the current Congress, but there are some people here from Washington think tanks who would be more likely to know if any committees are planning to look into that.
The statement was that the House Commerce Committee is planning to do that.
Hello, Sean Bigler, gentleman farmer, Gainesville, Zone 8B. So my question is, as a layperson, I want a question for Ross. I want some real-life examples of the social cost of carbon. Bring it down to an individual or, regional or demographic level, something that I can understand, and then I would like to propose a future study. What is the social cost of carbon zero?
The studies that are done that try to come up with the social cost of carbon, sometimes they look at things like, let's say in a warming climate, you're more likely to have longer heat waves, and that can damage agriculture in some regions. So a lot of them, though, are much more speculative than that, and they just look at large-scale correlations between economic activity and temperature. Does productivity go down in really hot weather? And then as far as the social cost, if you mean by the social cost of going to net zero emissions, yes, the mitigation policies are extremely expensive. Even small-scale mitigation is expensive, and that's why the integrated assessment models keep coming back and saying, okay, you could justify eliminating the lowest value emissions out of all the economic activity, but that's very little, and the rest of it you should be prepared to live with.
Richard would like to get in on that as well.
I have a question, Ross, and it's always bothered me a little bit. Where does the fact that rich societies deal with disasters better than poor societies enter to the calculation of the social cost? Because if the policies render us poorer and weaker, they're certainly leaving us less resilient. How do you factor that in?
Well, looking specifically at the agricultural literature, in the fifth assessment report, in the chapter where they looked at these studies of the effect of warming on agriculture, they They went to the trouble of drawing 2 lines for each region. One was the studies that assumed there's no adaptation, and one was the studies that assumed adaptation. And of course, if you assume adaptation, then the warming is pretty much benign and has no cost. And if you assume no adaptation, then yes, warming is a problem, but everything's a problem if you don't adapt. So I don't know why people bother doing studies where they assume there's no adaptation. You wouldn't survive the transition from summer to winter if you assume no adaptation. So just on a basic level like that, yes, people will run all kinds of studies where they make assumptions that even wealthy people don't bother adapting. But once you admit that adaptation actually eliminates most of the downside risk, that raises the obvious point that, well, then the best thing would be for low-income countries to grow and increase their income. And that was an argument that Thomas Schelling made back in 1992 when he did his American Economic Association presidential address, and he went through all the consequences of climate on the economy, most of which you could dismiss because most economic activity happens indoors. But to the extent that it happens outdoors, his conclusion was the best thing really would be for poor countries to become rich.
My name is Carr Ingham. I'm from Texas, and I'm an economist with the Texas Alliance of Energy Producers. The regulatory structure in D.C. and within EPA and the Biden administration in particular seems to be, if not pivoting to methane, certainly a heightened, much higher focus on methane. They're quick to point out that its warming characteristics are vastly greater than CO2, but slow to point out that its concentration in the atmosphere is much lower. But both from a physics and economics perspective, I'm wondering about methane in and of itself as a climate danger. And whether or not there's any remote justification for this heightened focus on methane regulation, attaching a fee to methane from oil and gas production and then on down the stream. I mean, this is what we're looking at, and this is what oil and gas producers and others involved in that industry are presently facing in terms of regulatory threat.
Is Will Happer here? Oh, you should answer that. Yeah, I think that would be advisable. Will has studied that.
Get the mic over to Will. It's Professor William Happer of Princeton, Emeritus.
Well, let me try and say something without.
He's getting your microphone there.
Yeah, per added methane molecule, one methane molecule is worth 30 roughly CO2 molecules. So yes, it's 30 times more effective per molecule than CO2. But as I think the gentleman pointed out, the rate of increase of methane is much slower than CO2. Methane is increasing 300 times more slowly in the atmosphere than CO2. So you divide 30 by 300, you get 1/10. So methane's contribution to warming, and whatever it is, it's about 1/10 that of CO2. Now, the other thing about methane is that it doesn't last long in the atmosphere. It's got a lifetime of about 10 years, 8 years, something of that order, because it gets oxidized, it burns. And so the IPCC, as is their wont, says, well, we can make that into an amplification mechanism, so we might be able to double the effect of methane because it oxidizes up in the stratosphere to water, which is a very potent greenhouse molecule, the most, then it will amplify the effect. So they're able to make that number of 30, maybe 40 or 50, but it's still trivial. So the answer is that there is no reason to regulate methane.
But the gentleman, he's had, this gentleman in the white has had his hand up forever.
Just let me hold on.
Hi, Ron Birdie, Free State of Florida. In Fred Singer's last book, he mentioned that there was very little, we really don't understand natural variation. There's been no money put in it. I was a little surprised to read that from Fred. Is that your understanding? Do we not understand natural variation? Have we not studied it at all?
Well, the answer is no, we're not totally ignorant of it. You have all sorts of things, the Atlantic multi-decadal oscillation, ENSO, El Nino. You have many phenomena that go over periods from 4 years, like El Nino, to ocean circulations that might be on the order of a millennium. We know they're carrying heat toward and away from the surface. The surface is not in equilibrium. Sure, a lot of things about natural variability are known. We know that there are things like the quasi-biennial oscillation in the stratosphere, which is saying that the average period of the circulation there is about 26 months. We know the models don't replicate it. So you're caught in a situation where, for example, you use a model that has no natural internal variability to estimate how much it'll change. No, we're not ignorant of it. We do know the models understate it, often completely miss natural internal variability. We know that nature has internal variability that's profound. Look, the sunspot cycle is 11 years. It's a big cycle. Is it forced from something? No, it's internal. Our magnetic field reverses every so often. Is that from some external force? No. Internal systems vary by themselves. They don't need any forcing. And we know that.
The social cost of carbon is obviously being used as a weapon, in justification of radical changes. One model that we used to think of as the reality check is the EPA's own MAGIC model. Would you comment as to the value of the MAGIC model as a contra to some of these other models?
The MAGIC model, as I understand it, is a very simplified climate model. So you can run scenarios in it and get a handful of aggregate global average measures out of climate outcomes. So in that sense, that can be used as a way of checking the simplified climate models inside the integrated assessment models. It may have been done, but I'm not sure that it's actually been done. And it is something that's on my to-do list. A colleague in the UK has written about problems in the integrated assessment models that they get not just too much warming, but it happens at the wrong time. And so I mentioned the Rowe-Baker distribution. Gerard Rowe actually wrote an article a few years ago criticizing the use of integrated assessment models with high climate sensitivity, because he said the MAGIC type models, you can have a high climate sensitivity, but the time to adjustment or the time to equilibrium then stretches out a long, long time. So it might take 1,000 years to get that much warming to happen. Whereas in the integrated assessment model, if you increase the climate sensitivity, it'll give you a lot more warming, but on exactly the same schedule. So the warming happens way too fast in integrated assessment models. I haven't really seen much being done on that point, but it's a good point, and I think the climate component of integrated assessment models really deserves a lot more scrutiny.
By the way, Bruce Everett at the CO2 Coalition has I think, a code available to anyone. It may even be a simple spreadsheet These integrated assessment models are not very complicated. Any of you can run the DICE model on your PC or Mac and fool around with the different parameters involved. And the point of Bruce's code was to show you you could get any social cost of carbon you wanted.
This is, we're quickly running out of time. This is going to be the last question.
Well, okay. All right. Well, you have to, okay, thank you. Just an observation I'm Ben Zeiker from the American Enterprise Institute. Ross, on one of your slides, you had just a very passing reference to the use to some economists arguing that for a discount rate lower than 7% on the grounds there's a long time horizon. You know, because you're a much nicer person than I, you really didn't mention how venal, I mean, really what they're arguing is that intergenerational equity requires that. And as if future generations would be better off inheriting a capital stock less valuable rather than more valuable. And just to demonstrate how venal it is, if you look at the regulatory impact analyses from the Biden administration, they use a 3% discount rate applied to the benefit stream, but a 5% discount rate applied to this cost stream in these proposed regulations. And so they're biasing the analysis in favor of the benefits rather than the costs. It's really much worse, frankly, than you have suggested.
Back 15 years ago or so, the Stern Review came out from the UK government, and the Treasury expert, Nicholas Stern, argued for very aggressive emission control policies on the basis of an analysis where he had a discount rate extremely low, about like 1.5% or below that. And he took a fair amount of criticism from people like Nordhaus, but also Amartya Sen and other of his colleagues, who pointed out that if you use that kind of discount rate, you are privileging today's wealthy at the expense of tomorrow's poor. Mm-hmm. And it's the distributional consequences of using an extremely low discount rate are, it's an approach that we wouldn't take in today's world. We wouldn't want policies that deliberately benefit the rich at the expense of the poor, although I say that and I think, well, that's what most climate policy does. People seem to like it quite a bit. But in principle, you don't want to be doing that, and that's the downside of an extremely low discount rate.
Yeah, climate policy is the transfer of wealth from the poor and rich countries to the rich and poor countries, right? Thank you. Sorry for my inadequate introduction, but I want to take time to thank our speakers. Got 15 minutes for a break and then lunch across the hall.
Okay. What a mess.
Vehicles, no matter what fuel they're using, inspected to produce a global warming rating. And he had to produce this crazy sticker to put on the side of the vehicle in order to be able to sell it, to give it a global warming rating. Now, they couldn't just simply do something simple like have some inspector look under the hood and go, oh, yeah, it's electric, no emissions. No. California, in their infinite wisdom, made you go through dynamometer tests, emission sniffing tests, all of that crap in order to sell an electric vehicle. And they wanted $30,000 to do this test, and there was only one facility within reach of me down in Los Angeles, that's 600 miles away. Anyway, bottom line is that California killed my electric vehicle business because vehicles. Basically, he pointed out some really interesting things that, Jim, if you have that URL up, I'd certainly appreciate bringing up that webpage. But in the meantime, I'm going to turn it over to Linnea and see what you have to say about electric vehicles. You've had some experience with energy density. What do you think? You're muted.
Sorry about that. The chart says it all. I mean, the battery issue in particular is one that I think is a little bit hard for people to really wrap their head around. So you get an electric car, and the first thing that people who have to replace the battery on their electric car find out is that it's nothing like replacing the battery in a normal car. The electric car battery tends to be like the entire undercarriage of the vehicle. It's crazy. I've only recently actually seen what that looks like. And I had been assuming that it was quite a bit of a smaller battery pack. And it's unbelievable. And these lead acid batteries in particular that you're talking about, well, if you're concerned about the environment, the construction and the manufacturing of the lead acid batteries in China and India, there's a couple of studies that have come out that have shown that it's actually leading to some pretty severe lead leakage into the environment and into potable water sources. Yeah. So there's a lot of questions. And of course, any industrial operation is going to come with some degree of risk, depending on the location, some more than others. Places like China don't seem to care very much at all about that kind of leakage. So it's going to be a lot worse coming from them than if the United States were manufacturing these things. But there are a lot more questions that need to be answered in regards to the environmental friendliness of an electric vehicle than we're led to believe. You know, when people's only concern is carbon dioxide, they overlook a whole lot of other issues.
They sure do. They sure do. Let's go back to that webpage real quick before we get to you, Sterling, because I want to point out something to people. Jim, if you'll scroll down just a little bit. Jim Lakely, our producer, is working in the background for me today. If you'll scroll down a little bit, the analysis that Willis did basically found that over the past 10 years, the amount of gasoline that was saved by electric vehicles, even though they're growing exponentially, came down to 2 days worth of gasoline compared to the whole U.S. consumption. That's what we've gotten out of electric vehicles over the past decade. It's futile. I mean, there's no impact of any significance towards reducing CO2. Sterling, what do you have to say?
Yeah, billions in subsidies, 2 days worth of gas saved. Probably less of an impact on gasoline consumption than even ethanol, and ethanol has almost no impact on gasoline consumption. You know, there are you talked about full disclosure. I've seen some comments where someone said they had an electric vehicle. My mom has a hybrid vehicle, and she has for a few years. With the warranty's out, her battery pack goes out. The battery pack costs more than the car's value. Yep. If it were a normal internal combustion engine, she could replace the battery and the transmission for less than the battery pack. Mm-hmm. And it would not be more than the car's value. Now that's for a hybrid. Can you imagine how much more expensive it is for a full electric? The battery packs there are much larger. They're much heavier. And by the way, you know, your shade tree mechanic can't replace those things. You have to go to specialized dealers. It turns out she took hers to Firestone. They said, we can't do this. You need to take it back to the dealer. Concerning your electric car, that wouldn't even be allowed in the United States to be sold today, Anthony. Leave California's particular idiocies aside. Under the Biden administration's plan for electric vehicles, it has to be largely made in the U.S. The component parts have to come from the U.S. They have to be built using union labor that pays prevailing wages. That wouldn't work. So, you know, this is both a subsidized jobs program and no good for the environment. Terrible for laborers in the countries. You know, basically, someone wrote this week, it's electric vehicles are the blood diamonds of the modern age because of the slavery, because of the forced labor, the child labor that's used to get the materials that go not into the lead, not into the lead, but into the lithium ion, which are the most common batteries for these things. And then, leaving all that aside, the damage it's doing to our electric grid and the damage it does to your homes if it happens to catch fire while it's just sitting there, folks. You know, one country after another, one state after another have pulled public electric vehicles off the roads when they caught fires, just sitting in streets.
Speaking of which, we have a video of what has happened to a Tesla when Hurricane Ian went through Florida. And the problem that we had was that a lot of the owners of electric vehicles chose not to use them for evacuation because they didn't want to risk getting stuck on the roads where they couldn't get a charge. And so they left them. And what happened to them? They got invaded with salt water. And as a result of being invaded with salt water, they caught fire. Jim, let's take a look at that video. It is fascinating to watch, and it's got captions here. This apparently, they tried to drive it after it had gotten salt water in it, and of course, it's out on the main thoroughfare. The problem is that lithium and water don't mix. Even worse with salt water because it corrodes into the battery terminals and so forth. And they're trying to put it out with water, and they're only making it worse.
I mean, to be fair, any car that gets flooded like that is going to have some problems. But most gasoline cars, I'm not aware of a single gasoline car in Florida, internal combustion engine car in Florida, that after the hurricane passed spontaneously combusted. I'm not aware of that. But dozens of electric vehicles did that. It's idiocy. It puts us in danger. It harms our electric power supply. And for me, look, I'm one guy, but for me, the most important factor mitigating against electric vehicles is they don't satisfy the way I travel or need. I did an analysis. There are something like 40 vehicles right now, electric vehicles that you can buy. If you want to buy them, you can buy them. And the government will be more than happy to give you a big subsidy if you do. It's coming from me, it's coming from Anthony, it's coming from Linnea, paying for you to buy your electric vehicle. Mostly pretty wealthy people buy these vehicles, so it's subsidy of welfare for the well-to-do. But there were only 2 vehicles being sold that I could get for sure to Houston and back. I mean, to Houston without a charge. That's if there's no traffic, if it's not too hot, if it's not too cold, you know, all the right Goldilocks conditions, then I could get to Houston. Other than that, every other vehicle, I'd have to stop for a charge. You say, oh, well, you have to stop to gas yourself up. Yeah, that's right. No, I don't actually. I can go to Houston and halfway back without having to put gasoline in my current vehicle. But if I had to stop, it would take me like 5 to 10 minutes. Yeah. If you wanted to charge an electric vehicle, the charging time at a fast charger, not your average charger that most of these are, but a fast charger, if you can find it, is 30 minutes to an hour for a 20 to 80% charge.
Right.
On a trip like I took to Colorado, I would have lost my entire vacation traveling to and from Colorado, stopping to charge that vehicle, rather than getting there overnight, coming back in one day, and having 5 beautiful days to enjoy my time with no charging.
Yeah. Let's get back to the fire for a second. Linnea, you've had experience working on oil platforms associated with, hard to put out fires. How would they put out a fire like this?
Right. So it's the same with any fire having to do with electronics. And a lot of, it's not just, it is mostly electric cars that have this problem now, but the more electronics you add to any car, the more of a risk you have of a fire that's difficult to put out because of the materials like lithium and stuff that go into them. So offshore, if you get a fire in an electrical panel or any place that there is battery storage, anything like that, what they can do on the drill ships that I worked on is they can actually close off the room airtight and suffocate and pump CO2 into the room and suffocate the flame out. And then when they know that there's no spark chance or anything, they'll send someone in to get rid of the equipment that's causing a problem. But yeah, it's CO2. It's
so what you're saying is, yeah, CO2, you know, you got to use CO2 to put out the savior of the planet for CO2.
Right. But I wanted to point out too, Sterling, with you talking about the range issue, there's a video that my dad sent me a while back from a YouTube channel that he enjoys. And actually this YouTube channel had a little bit of a controversy. The poor guy wasn't trying to get in the middle of any kind of political discussion, but he tried to take a Ford Lightning and do like a big towing project with it, and it just did not have the abilities that a normal pickup truck would have. And then he also went and tried to drive it around in the winter, and he ended up getting rid of it because the range was reduced by half in the winter because of the cold. Batteries don't operate very well in those kinds of temperatures. They also don't operate very well in high temperatures.
Yeah.
So there's a whole lot of issues, and it's not to say that the technology will never get there. Like if we have some random magic breakthrough in batteries, which they've been promising for decades, you know, who knows what could happen. So I don't want to dismiss the entire concept of an EV, but current EV technology can't be mandated because it's just not there.
Anyone who wants an electric vehicle should have the right to buy an electric vehicle. I got no problem with that. But I shouldn't be paying for their electric vehicle. I shouldn't be subsidizing that purchase because the government's decided these things are better when they are not. And, you know, you talk about Alaska. That's right. Alaska, there are cities in Alaska that try to replace their diesel bus fleet and their natural gas bus fleet, because they had some natural gas buses, with electric vehicles. They shut that project down. San Francisco tried electric buses. They pulled them off the road. It was either Connecticut or New Hampshire recently that the governor signed, one day he signed a bill saying we're transitioning our public fleet to all electric vehicles. And the very next day, the only city that had bought electric buses so far pulled its entire fleet off the road of 7 buses because one of them caught fire while it was sitting in a parking lot.
Yeah, it's just speaking of catching fire, I want to get into a couple of videos to help our viewers get an understanding of just how volatile lithium and water together are, or even lithium and air. Well, we've got this one clip here of this battery fire of a laptop type battery. Okay, now he's basically puncturing the battery with a push pin from a bulletin board. Look at that. That thing, this is why they worry about these things on airplanes. Yeah. With that kind of volatility, I mean, it's like a blowtorch going off. Can you imagine that in a confined space of an airplane? And they had problems like this with batteries, lithium batteries on transport ships. There was a fire a couple of years ago of a ferry boat where they had some lithium battery cars on the ferry boat, and the ferry boat caught fire because the lithium battery caught fire while it was being transported. Now we have another clip after this one that shows what happens when you put lithium, pure lithium metal, and water together. Now you may remember in high school you put sodium in water and it exploded. Well, lithium is twice as volatile as sodium when you put it into water. And not only that, it does something else that's very, very unique. Watch. It produces hydrogen gas. As you know from the Hindenburg, hydrogen is extremely flammable. And here it's what they do. They capture that hydrogen in a test tube, put it over that candle, and watch. Boom. So the lithium, when it reacts with water, it produces hydrogen gas and oxygen. It's a self-sustaining reaction. And this is why it's so explosive and so problematic. And so we have literally now hundreds of thousands, if not millions, of ticking time bombs out there on the road that if they get, in an accident or they get water incursion or anything, they're going to catch fire and burn up. And this is something that doesn't happen with gasoline or diesel vehicles. As Sterling pointed out, none of them spontaneously combusted during Hurricane Ian.
Well, but you said if anything happened. No. The problem is worse than that. It's nothing has to happen and they can still combust.
Yeah.
Just sitting there, the batteries can heat up when they're not being used, when they're not charging, they can catch fire. It happened in India with scooters. It's happened in the US. It's happened at battery battery backup power plants where the units were sitting there adding power to the grid, and all of a sudden, boom, fire breaks out. Now, I love the idea that you have to use carbon dioxide to put out these fires. I can see us, now the terrorist gets on the airplane with a cell phone, punctures it with a pin, sets off the fire, and they say, oh, we got to cut off the oxygen and pump in CO2. Everybody's dead, but the fire's out.
Yeah.
It's
well, that might be the
crazy.
next terrorist attack. That could very well be a terrorist
now that you
attack.
show me that, it's like, I didn't realize it was that easy. That scares me. And, it just gets worse and worse and worse. And government keeps plodding along, saying we're going to force the replacement. No new internal combustion engines after 2035, right? And where's the power going to come from? What are we going to have to do to the grid? Where is all the materials going to come from? We are trading energy independence. We went from energy independence to energy dependence largely on OPEC for a while, under Trump to energy independence again, and now we're going to have energy dependence on China. That's a good trade-off.